those that have just done little property surveys and never really dealt with elevation information, they're not used to working in that third dimension. So it's a nice little uh, way around it. So we'll take a look at that. We can save a little time there and stay a little more focused on hydro. That's good that you're comfortable with that. And there's a little exercise here on page 19, just
I'd still, still very much like to see how you do it.
okay.
Everything I know about it, I learned from our surveyors who are pretty good understanding like the 3D,
Let
the
me
aspect of Carlson and building real topographic surveys as to,
Yeah, all right. Well,
but
we'll go through a little quick refresher on that. Um, Although I see a big problem here, and I don't know why this has never come up before. I tell you, the reason we've never run into it before is that we generally always skipped over this for most of these classes for hydro. But it says for you to open the drawing file called sample from T3 Global. Well, guess what? You don't have that file. So
oh,
so let me send that to you. I'll go find it here and Dropbox. I'll get it out of say uh, simple. There it is. So if showable. There you go. Just grab that file and put it in your folder, and I'll do the same with mine. Let me switch here. Text, and
usually the waiting for it to come in. So
yeah, everybody's got it. It's like two dogs meeting up. They got to sniff each other, see if they're okay. So,
got your pen and software. There we go.
all righty. So we got that. So we'll use that to go over a bit of this, like how to evaluate the surface, the differences in um, just basically reinforce some good surface modeling techniques. And in fact, that's going to sort of set the stage for when we start to build up this watershed, um, the data set that you do have included.
Mhm.
And it would be, set the stage for that. So let's jump right in. Let's see. And there's 2024 with AutoCAD. I'm so used to the IntelliCAD versions now. I may trip across a couple of commands here if they're slightly in different places, so bear with me. Um,
Well,
so I'm going to open if this ever settles down. Oh, didn't mean to do that. Yeah, there we go. There we go. All right, finally. So let's see, where are we? Get out of my client files and into my teaching files. Here we go. All right, so let's open up sample from T3 Global. You just ignore any of those missing things. And let it go through its gyrations. Okay, don't need that. All right. Don't need that open at this point. Let's see here. Let me close this up just a wee bit. All right, so I generally, keep my like XREFs and stuff palettes over on the side, keep my properties docked but open. And one of my toolbars here that I use when I use the Carlson toolbars, the Carlson layers toolbar, it doesn't matter which one you use, but there's this layer, they have a layers manager, a layer manager that was, it's the same as on the view menu, it's layer control. That's what I'm trying to say. And uh, see, well, that's not, put it on their layers toolbar. Where did I wind up?
Properties manager.
I think, no, it's this,
Next to the left of the drop down for that zero layer box. Is that it?
this bit here. No, that's just in the properties.
Well, you trying to bring up the
Well, it's this layer control. It's this palette that's,
okay.
and I think maybe AutoCAD used to have it as a separate. Oh, I know what it was. It's so there's properties, design center, tool palettes. Thought they put it into one of these palettes. Well, it doesn't matter. Um, since I do use it, I'm going to keep it docked over here though. And won't keep it docked, but I will let it auto hide. There we go. I'll just keep it over there handy. Um, and in the IntelliCAD version, you get an interface like this, but instead of just dealing with layers, you've got all these different categories over here. You got layers, text styles, all your different paper space layouts that have been defined, blocks, XREFs, everything that you can get to from there. And you can have multiple drawing files open, and you can use this like, I don't know if you're familiar with Design Center, um,
Wow.
which is how you can drag and drop, different things between drawings, like share blocks or layouts and things like that. And you just basically drag one and drop it onto the other and all that. It's really nice and handy. But anyway, I digress. We won't talk too terribly much on that. So now, so a couple of things that we want to keep in mind, particularly for what we're doing, um, is that we need to model our surfaces fairly accurately to be able to, have the system help us in determining where water is going to flow and, catchment delineations, things like that. And, it comes with its own set of, uh, how much is too much, and, are you building a Cadillac or a Volkswagen kind of question. So, if you're doing a 5 county, storm modeling study, you don't necessarily need to have, every little whip stitch, back of curb, top of curb, and all that kind of stuff figured out. You can pretty much do it on a much coarser basis. But when we're doing things like, subdivisions or commercial property development, where we're trying to figure out, flows and where best to place our inlets and collections and all that, then we're going to need to model those flow paths fairly accurately. And this is the biggest issue that I run into. So with a lot of users. So but it's this reliability or false security, if you will, on what they may have for for the origin of that surface information. All right, and you'll see what I'm talking about here in a little bit as we go around it. So first of all, what you're looking at is a file. It's an actual photogrammetric compilation of a site that's down here in Pennsylvania. And by the way, I'm right outside of Pittsburgh is where I'm located. I saw from your information you're up in Massachusetts. Yeah, Framingham.
Yep. Yeah,
So,
it's outside of Boston.
oh yeah. So the Carlson the hydro team, as far as I know it, I believe it works out of Waterford. Is it Waterford?
That sounds familiar.
It's I may not have the name of the town right, but it's just outside of Boston as well. But that's their main programming center. Even though they're headquartered down in Kentucky outside of Cincinnati, but
Westford,
yeah, I think it's Waterford.
Waterford, Connecticut.
No, it's not Connecticut. It's in Mass. Must not be Waterford. Waterford, Virginia, Connecticut, Michigan. Well, there's a lot of Waterfords all over the country, but it's not Waterford, apparently. What else is up there? Let me see. Something that starts with a W. It's not Woburn. It's not. All right, I see where you are. There's Worcester. Well, it doesn't really matter, I think, but I thought it was bigger than what this is showing me. Winchester. No. Well, I don't know. Let me check one more little quick place here. Watertown. That's where they are. So
Oh, okay. Yeah,
yeah,
yeah, right outside of Boston.
yeah. So it's not Waterford. Sorry about that. Yeah. Anyway, um, but yeah, that's where most of their programming staff works from. They have some obviously all in different places all over the country, Georgia, some overseas actually, but um, the central location is there, Watertown. All right. So anyway, so what we have here is this little site. Again, it was compiled photogrammetrically, and it's got a number of different things located here. In fact, if you look at your drawing inspector and maybe just turn on the layer name, see they're using just standard CAD type. There's V topo miner, so that's a survey. minor contour, there's a major contour, there's a tree line for V-site veggie. There's all these other little random looking white lines. These are the break lines that they compiled through the photogrammetry. So I'll go ahead and turn that off. And that is really, when you have that kind of data, that's what we're going to use to build our surfaces with. But here's what I want to have you go through real quickly is to see why and what the differences are so that you can appreciate that a little more clearly when you get into some limited data sets. So the first thing let's do is I want to freeze the layer that say these white lines are on. So I'm
The topo break line.
no, it's yeah, the break line layer.
Yep.
So I'm going to just freeze that by pick. And if I, by the way, if I do any particular command that to me, I may think uh, that you know and understand and use all the time, but it may be something that you're not ever using. Like, uh, just stop me and say, hey, what'd you do there? How what was that command? Because we had I remember I was back, oh, 15 years ago, maybe I was actually in Carlson's headquarters down in Kentucky, and they had this woman. She was a PhD mining engineer, and she was from Russia, and she was a professor and taught mining engineering to these uh, Russian coal mining companies, and they were using Carlson. And part of that part of that software would do things like when they would build out the mine development phasing, it would create these different structures on a series of different layers. Okay. And it was usually an iterative process. So you would do some settings, you hit the go button, and it would generate all of these different things. Well, you look at it and you say, well, that's not quite good enough. I want to try something else. So you have to clear all that out and then change some numbers and go back and recompute. So what she was doing every time was freezing or isolating. She would run the command, to isolate layers. And she would isolate those layers, select everything, hit the delete key, and then unisolate the layers to come back. Well, that's fine. But there was a command that's, been around since day one in Carlson, this erase by layer. And it has this nice little thing. You can select the layers from the screen and you can pick these different layers and, whatever one, just give it samples. It fills this list out. I'm not going to do it. I don't want to erase those. But you go and then you can, limit, you can filter what you're going to erase from those layers or everything.
Mhm.
And then you pick that once, right? And then it clears those out. And then you just pick something from each of those layers once. You run your command, you look at it, you don't like it, you want to change your numbers. So all you have to do is run that command again, and that list stays populated. All you have to do is hit the OK button until you're satisfied with what you want to keep, and then you don't do it again. So to her,
Erase by close polyline. Oh, that's
yeah, and she had never seen that command. So that's what I want to encourage you to do is if I do something, if it goes by quickly, or if it's something that I may think is something that you do all the time, but if it's not, be sure to stop me and let me know, okay?
okay.
So,
Speaking on that, how did you set up that just so your cursor would display the layer just by hovering over it as opposed to clicking on it and looking at the prompt?
go to your inquiry menu and choose drawing inspector on and off.
Sorry.
Now, nothing happens except that the command line, it says the inspector is on.
Yeah.
Right click to activate the pop-up menu. And when you do that, you get this. And when this pops up, you choose what of these lists down here that you want to see. And I had display layer name on, but you can also I'll leave that on, I'll leave it checked. I'm going to choose display elevation. And if I want to see something else, so now you see I get the elevation as well the as the layer name. You can also right click and turn on, oh, say, polyline data. So if you point to that and it tells you now there's my layer name, my elevation, my horizontal distance of the segment that I'm on. So if I were to click this, so it's that segment right there between these two grips that has a horizontal distance of 30.772, a slope distance of 30.772, because obviously it's a non-elevated, it's a 2D polyline. And it gives the elevation at the start and the end, and it reports the slope in percentage and in ratio, gives you a total distance of the entire polyline. And see the total horizontal distance, the current distance, I'm not sure I understand what that is. Oh, the current distance is the distance from the start. That's like the stationing along that line. It has a total distance of 1,262 feet. And so I was at that. So the closer I am down here. Anyway, and that just hovers. And
What what was the to turn all of that stuff?
you right click the mouse. Once this is running, you right click the mouse. You want to make sure it says enable tag display.
Okay.
So
I
that,
will, okay.
so,
Enable
and
tags.
then these are all, and like if you want, you can't pop this up and then say pick, pick, pick. It's pop it up, pick, pop it up, pick, pop it up. You have to do it one at a time. Um, but again, it stays sort of running in the background, and you can, you know, go back and do other commands. It's not, nothing prevents you from doing that. Other than it does take a little bit of processing. So I really only use it when I'm in explore mode. Um, so, take take a little bit of I would turn it on and off. And really the only indication that it is on is, well, first of all, if you right click the mouse and you get this, then you can issue a keyboard enter. You can exit this menu, which all it does is just dismisses the menu.
Mhm.
And if you get the options dialog, let's see. Oh, look at that. That's new. This options dialog. So now you can go through here and say click, click, click. Ah, clever. All right. Well, that's much nicer. So that's the options dialog. And then you can turn it off from here, or you can go back to the inquiry menu and just run it again. It's a toggle. And now look at the cursor. You see that standard AutoCAD cursor?
Yeah.
But when it's on, my drawing inspector, now look at the cursor. It's the Windows arrow that you typically see and the AutoCAD cursor together. And they're supposed to be synchronized, but you see one lags the other one a little bit.
Yeah.
How about that? This options dial, I never knew that was there. That is new, but at what version of the software, I'm not sure. It's been around at least since 2024. So anyway, that's sometimes something that you might find a little more handy than doing other things. Since you did ask of that, there is also, and you have a similar thing in AutoCAD, this layer walk, but there's also this view, what they call this layer, or I'm sorry, inquiry layer inspector. And it docks this little dialog down here, and you can, walk through the different layers, and you can, select multiple layers. And over here, you can isolate or not, zoom or not, restore the view and exit. You can step in and out of this list. You can rename a layer. You can erase the entities that are on those layers, at which point the purge button becomes active. So it's a nice little, you know, way to sort of explore your drawing. Another thing that too that I like to do sometimes, are you like, well, I use this 3D viewer all the time, and I look at things in 3D to, what if if my project involves, using elevations. Um, One of which, you've got these, all of this kind of navigation with the cube and stuff like that. There's a shortcut to that if you just hold the shift key down and press and hold the wheel on the mouse. That sort of lets you,
Well,
bring it up to sort of a shortcut. That's something handy. But Carlson has a very nice, uh, this 3D view drawing viewer where you that
view,
it's in the view
3D
menu,
view,
3D view drawing viewer. Do you use this at all?
3D view. Um,
On
like
the
entities.
Yeah, the view menu, 3D view, and there's
Oh,
draw
is this similar to like
like the object.
the tin surface manager or something? But
Um,
doing other
well,
entities.
I mean, there's a number of ways you can look at things in the drawing. And like AutoCAD has, or at least AutoCAD, like Civil 3D has an object viewer. Let me see if you select certain things and then right click. It's not on the menu. It's usually, there's your isolation, but it's usually down below here. But the object viewer, when you select like a surface or an alignment or something, let me see if it's object. No, it must require, yeah, it must require Civil 3D or maybe AutoCAD map. I'm running this on just plain vanilla AutoCAD, so it's not built into it. But anyway, it's a means of selecting something, or if you select a surface and then you go into that viewer, it really just keeps you in that interface. Carlson's viewer, however, this view, 3D view, there's two main ones. There's this drawing viewer and the surface file viewer, and they're actually one and the same viewer, but it just matters as to the drawing viewer prompts you to select objects in the drawing. The surface file viewer prompts you to select a surface file that you've made and saved. Okay. And it puts it in a viewer. And there's a number of tools in there that are really, really handy that you don't get out of just viewing things in 3 dimension. And we'll go through those as we work along. Um, it's really, I would encourage you to explore that if you're not using it. Uh, but I mean, because I do this all the time. In fact, these two, you see this toolbar, when I hover right here, it's my Carlson Surface toolbar. This second one down horizontally all the way to the left. And on it are these two icons. There's the one that looks like this three-colored cube. That's your 3D viewer window. And in fact, if you read the help line there, it says allows you to view the selected 3D faces, polylines, lines, and points in 3D, colon, and then it tells you the name of the command is called cube. So that's the Carlson command cube. And then you can skip over, this is a surface flyover, which is also pretty neat, but it gives you, a lot of other things that you may not be looking for in the other viewer. And the next one here is this surface file viewer, and you see it looks like a little pyramid or a cone. sitting in a computer screen, which is supposed to be reminiscent of looking at a three-dimensional something on a computer screen. So that's the two choices. If you use the 3D viewer, it asks you to select and it, only gets what you select. And it pops up another window, completely resizable and all of that. And you've got switches that allow you to, ignore zero elevations or not, set a vertical exaggeration or not, set the light position. Uh, then you got different settings and you can load up surface files into this. Whereas likewise, if you load a surface file, you can load up drawing elements into it after you've done it, et cetera, et cetera. But anyway, it's a nice little interface. And you can see it's, if I'll turn off, different, a little different viewing controls. Let's turn these off, set our color by elevation. So it, gives you a range set of a spread of colors for different different elevation information. So anyway, we'll use that as we go along. But if I do something in there, and by the way, this viewer, once you have a surface file and you load the surface file up, in fact, if I go out of this and go back into that alternate command surface file viewer, I'll go up to from break lines and spots. I think it's, yeah, this is the same file. So, here's, we didn't do the exterior trim on this, but this is this same site. You open up the, first let me turn that off. And let's look for me, e.g. from contours. Yeah, here's one of the, this is, we'll go through this ourselves and you can see, here is, here's the biggest problem. I'm going to go to add this one now. And I'm going to turn on. So this is looking down the road. And if I turn that one off, turn this one back on, here it is when it's built with contours only. And here it is when we got the brake lines in. So, you'll see different things there. One of which was over here, for instance, at this loading dock. We'll see that one and we'll turn that off. And so there, and this is again, the same file, but you see all this mess over here that
Yeah.
didn't happen. And, this will display contours. You can set the contour interval to be, different things, and it shows all this in real time. But the other nice thing is if you are one of these people that edits your surfaces by manipulating triangles, then this is one place you can do it. You can also do it back out in the drawing, but this is kind of nice too. We just choose our arrow and then we come down here at the bottom. Now this is if you're in the surface viewer. If you're looking at the drawing viewer, it doesn't have these controls because it knows you're not working with these surfaces. So here's where you can say add a brake line, and there's a brake line maybe that went from here, maybe from there to there.
Oh, so you can edit them right from here?
Yeah. So if I go from there to say there, See, so now I've done that. I've got a little more, I've got that big giant ramp taken out of the way. I could, let's see, like right in here, for instance, get my, yeah. So I can add a brake line, say from here to here, here to here, here to here.
Now, is it just like snapping to like the points that's there and making a break line between them?
Yeah, yeah. It'd be the very same thing as if I had gone out here into my drawing and the drew the brake line. But now, which brings up the obvious, why wouldn't you, instead of doing it here, now once you make these edits, when you go exit, it's going to prompt you if you want to change it and ask you to give it a different name. Now, the the obvious question is, well, why wouldn't you come back to here and put the brake lines in and just rebuild the surface? And that's my recommendation, because when you make an edit to a surface, if you do anything else later on that recreates that surface, you have to go back and redo those edits. If I come in here and I find, oh, there's a problem in here, I missed something, I want to add it to it. You either have to, add it and do a surface merge and all that kind of nonsense. But what we would do with if you do your edits by editing triangles, and sometimes you'll get like zigzaggy looking contours, and people will go in, they'll start swapping edges, which all
Yeah.
you're doing is making the contour look pretty. It may or may not be valid. So, it's sort of a bugaboo. It's a workaround, but that's the way a lot of people do their surface modeling. And everybody gets by with it because the poor contractor is the guy out there holding the bag, and he's got to make it work. And that's that's usually
Yeah.
how it happens. But anyway, so we'll use some of those tools. But again, if it's something like that that you haven't used before, you don't see, and you need me to go over it, be sure to let me know, um, so we can do that. But now, here is what I wanted to show you. So you've now got your drawing like this with those white lines are now frozen off. Is that correct?
Yep.
Okay. So you may notice a bunch of little points over here, and they're just AutoCAD points. They're not Carlson points. Okay. They can be turned into Carlson points, but and if you see, isolate. See, there's quite a few of them here in this drawing, and those are, you think of those as spot elevations. Okay, so they're in here, and that would be included in what you were building a surface model from, that and those ones. So I'm going to actually also freeze those points. So now, they're not part of that data set. So I've got essentially this. I'll show you what I've got. I've got these two layers, VTopo DTMP, or digital terrain model point, and a brake line are frozen now. So if you'll do those, and let's take a look at what is a typical workflow. And again, I don't want to dwell too much on the surface stuff. We got one day to get through hydro, so we want to make sure we do that. But it's important to know how to do this and know why and what the processes are. Um, when you're doing a design, you're typically going to come up with, and you said you're somewhat, familiar with the process of, you know, excuse me, creating these elevated edges is what I refer to them as. We design like a parking lot edge goes from this elevation to that elevation. So you're familiar with 3D polylines, and that's how we, create our design. And it's done typically on top of a base terrain. We have an existing grade, and then we'll have a final grade or design grade. And a lot of times, and I've seen people do this, they'll get the existing ground information, maybe from a sub-consultant survey firm, and they'll get a contour map, and that's all they have. They'll have something that looks like this right here. Okay.
Yep. Yeah, I get that usually when I'm working with outside surveyors,
Yeah. So,
just
but
that.
what you don't get, and if you look at it, it's pretty nice. It's pretty detailed. I'll pop this thing up into my viewer, and I can see this. Uh, it's all very representative of what's out there. They got some nice, the contours. I can look at that and see what that looks like, right? But if I go to build a surface from this, if I go to my surface command and triangulate and contour, I'm going to I'm going to write a file, and I'm going to say uh, select. Let me go to my hydro class, and I'm going to call this one EG from contours as a name in there. Okay. And I will uncheck this use inclusion because I did not shrink wrap this thing. I didn't draw a boundary yet. I'm going to let it do it. And I'm going to say a medium reduction in my external triangles. And that's it. And I'll go ahead and draw these contours. I think, what are we on? Ones. I think. Let me see. I'm on, yeah, ones. All right. So back here, write the file, select. I'll be in here. We'll call it EG from contours. I will ignore zero. I will do this shrink wrap. Go ahead and set this up. That's good. I'll draw 1 foot. I won't label them, no filters, and I'll say, okay. Now, so if I were going to do this, and if I look at, the only thing that has elevation here are those contours and those spot elevations. So if I were to create this as a surface, well, off it goes, it creates a surface, doesn't give me any errors, right? And I've seen people actually train people to say, congratulations, you just built a surface, yay. Well, look at the difference. Let me turn on theirs. Let's see, V. Topo, let me go by name here again. Major and minor, for instance. I'll make them a little heavier. So their original ones I've turned on heavier and left our, ours are red and white. Theirs are green. Let me see, what is that? Oh, minor. Okay. Minor and major. Let's give them a little heavier than that. They're not showing up very heavy. All right. So you can see the original drawn contours, which like this one here, crosses the road and comes all the way up to here and then climbs up the face of that little wedge curb and then goes back across this flat walking area, comes up here, comes around, comes up here. And so there's a nice ditch there with inlets in it. But look at our contours, which mostly match, but you see what they've done is they've cut off these little triangular areas, right?
Mine followed the triangles, but it kind of rounded them off a little bit.
Okay, so what happened with yours is this. So when I go back to here, I'm going to clear this. I'm going to take mine out. When you ran your command, I'm going to guess you had on your triangulate tab. Go ahead and run this and check for me. And look down here where you might have had minimize flat triangles was turned on.
Yep.
All right, that's something that you always want to do if, and you see the little title in this little section here, it says adjustment for source data of contours. So you do always want to have that on if you're building this from contours and you don't want to have to go through and draw the break lines. But if you don't have that on, you would get what I got. And on your contours, you've got some kind of smoothing going on.
Yeah.
And
I think
again,
it's
realize
7.
when they're curvy like that, that doesn't represent a smooth surface. That represents a drawn polyline that has had smoothing applied to the polyline. The surface is still exactly what the surface was, which is one reason I like to not use smoothing. And if I need something that actually represents a smooth surface, instead of trying to cosmetically make that happen with drawn contours that I've smoothed, I'll put in enough break line data to smooth that transition area out. Okay, that's sort of this is the more honest approach is if you don't do any smoothing, you can see what those triangles are actually doing, and then go and fix problems in the data, rebuild the surface, and go from there. All right. So in any case, let's see, well, I've already built that surface. And now if I look at that in my surface viewer, I go to my view menu, 3D views, 3D view, surface file viewer, or I pick it from the toolbar. And I'm going to get that EG from contours. Let's see. Let me get back. Sorry, let me get my folder. So here it is with, all right. And you can see because, let me go to my model tab. Uh, my opacity back up. There we go. So now if I look at that, you can see how those break lines were not picked. Those are those flat areas in those contours, right? And you can see them. And if I go back and add to this, say these contours over top of my drawn contours, you can see their original contours drawn here, but my modeling cuts them off flat. Now, what does that do to what we are about to try to figure out what we're going to be doing? And so I'm going to exit that and I'll show you real quick, a real quick um, illustration of why this is sort of important if you've got some means of mitigating that problem, either drawing in the brake lines after the fact, after you get them, or making sure you, or maybe not, or maybe and making sure you use that switch to minimize flats. But if you go to the either the uh, either the civil or survey, I don't think hydro has this particular command I'm looking for. If it would be under surface. No, go to either civil or survey. If you've got civil, look on the profile menu and choose quick profile. If you've got survey, go to the surface menu and down at the bottom in the profile sections, choose that quick profile.
Mhm.
Oh, wait a minute. Let me see. Yeah. Well, yeah, we haven't built the other surface yet. So um, I do happen to have that one built from the model. Uh, hang on to that. We'll come back to this command here in just a minute. I want to show you a difference because I want to show you with the two files. Um, so that was, I made the one surface model from contours without using the flats. That's why you had those flat areas in here. You know to use that. That's good. But a lot of times people don't know that and they'll wind up with that as a problem. Now what I want you to do is go back out to the drawing and let's turn all the layers on those two that were frozen. Go ahead and turn them back on, thaw them back on. And now I want you to, we're going to freeze the contour layers. So we've got 4 layers, maybe even 5 if we get the labels, if they're on a different layer. But I'm going to go here to the view menu and choose freeze layer by pick. And I'm going to pick the contour label, the major contour, the minor contour. And then I see I've got these over in this obscured area. I'm going to get one of those and one of those. And now they are turned off. You should have your drawing looking like this now, where we've got these break lines now are back out. And if I look at that in my 3D viewer, this will show me my break lines. It will also show those points a little more prominently. And I can see, wow, that's really all the data that I need to model this surface. And right here, if you remember that big jumbling mess at this loading dock where I put that brake line back in manually with the surface viewer, well, here you can see the brake line's there. They've got it in their data. The brake lines are here, over here in this roadway, if I can line it up for you here. And there's that wedge curb, that flat walking area. You can see like right there's the face of curb, the back of curb, and then over here on this side is the ditch line. So all of those things are there. And I would be much better served if when I get my base mapping in from my surveyors, or in this case, the photogrammetrist, if they have prepared this using break lines and points, that's the data I want to build my surface from, not the contours. I may use their contours because they drew them, and I just may have them there for mapping purposes, but I'm going to build the surface from the same source data that they used, which are these break lines and these points.
Yep.
And so now I would do that triangulate contour. And I'm going to change the file name and I'm going to say EG from break lines points. And let's see, let's do, yeah. Step that up to high a little. Maybe let's, yeah, I don't know. Doesn't matter. And I'll say, no need to worry about that. I'm not taking from contours. I'm not going to draw the, well, yeah, let's go ahead and draw them again. I'll say, okay. I'll get my data. Now, there is a couple of errors in their data. They've got some crossing break lines, some vertical edges, and you would, just go in there and right in here, it happens to be right around there's a head wall in here. It gets, yeah, right there it is. So right here at this head wall, they actually cross over top of, the one's supposed to be the back side of the wall and one's the front side of the wall. So, we would go through and figure out how to resolve those errors. It's not that big a deal. I'm not going to bother doing it here just for these purposes, so I'm going to exit that. But in that case, we now have with their surface viewer, this one from the break lines and points, which you notice nice, sharp, indicated curbs over here where that loading dock was. All of these over here. So we get all of this extra definition that we never got when we took it just from the contours. Okay. And now that we've got these two, I'm going to go back now and just for clarity's sake, I'm going to freeze off those. Break lines. Let's see. Get that going. There we go. So now I've got their contours and my contours. And we got a couple of little zingers right in there, but look at how they go up into these nice defined gutter lines over here. Everything's nicely follows theirs. We just got a couple of little spotty places where we've not agreed with theirs, but for the most part, we're just dead on it. Right. So another good comparison, and this is now we're going to get back to that tool. And I'm going to freeze mine. We'll just go from theirs. Is on the quick profile command. Now, do you have this command handy?
Yeah, profile, quick profile, yep.
Yeah. Do you have civil?
I have both. In the moment, I'm in civil, but I can
Okay.
switch.
All right. Yeah, that's fine. Let me just match you. So I'll go here under profiles, quick profile. Now, we're going to, instead of looking at screen entities, we're going to look at surface file. And we're going to give it two files here. We're going to choose the first file, which was my existing ground from contours. And my second file will be my existing from break lines and points. So I've got two files. They're one over top of each other. I'm going to say, okay. And now it prompts me to pick a starting point or use a center line. So I'll just come down here and grab this point right here on this ditch. And I'll come down and say, run down toward this inlet. Okay. Let me try it. There we go, right in there. And then hit enter to finish. And now you can see, let's give this a little vertical exaggeration. So what we've got, uh, as I get over here in the profile view, what's going on? So you can see the two different surfaces that I'm looking at as I track down that line. You see where I hit those flats in my bad surface. And so I'm right here, say, you can see over here on the right-hand side, that elevation is like, well, 1309, and it should be, I'm looking at that's 1309 there, and it comes down here to say 1308. So it should be about 1308 and a half in there. Instead, it's 6 inches too high. All right, so I get this set of stair steps instead of that nice red line, which is what I'm looking for to figure out my flow regime so I can, model the flows in those gutters. So that's why it's important to try to do this stuff, correctly and understand why we're, uh, well, to model, what our surface as a basis for what we're doing with the hydrology. There's another case of, this is weird. The AutoCAD version scrunches up the horizontal. See how it's compressed up here in the plan view? It doesn't do that in the other. But anyway, I'm going to adjust this and say, click near it here. Now watch as I move this around. You can see in some areas, like if I get right in those flats and then yeah, so now well, it keeps resetting the zoom level, but you can see where's this? Now, you see right in there that the difference in that surface, those are those big giant things that were down here in front of this retaining wall.
Yeah.
All right, so that's really the illustration. Now, we're not going to spend a lot of effort and a bunch of our class time trying to figure out the nuances of that, but sort of be aware of that and pay close attention to it, okay? To where we have to either use break lines or minimize flats or sometimes both. All right.
Yep.
So, you'll see that because the data set that we're going to use to do the pipe network in a class is necessarily very simplex. And you're going to see basically a bunch of contours and nothing's prepared right. And this is what, the folks at Carlson will use as their demonstration uh, data sets. So we can fix it to make it work a little bit better. And it is good knowledge to have because quite often that's what we are given and what we have to work with. All right.
Yeah.
So we'll come back. We're right at our mid-morning break point, which is odd for me. I usually run about an hour past and say, "Oh crap, I forgot." So, so we're going to take a little 15-minute break, and then we'll come back and we'll get things set up, and we'll see how Hydro takes care of the rest of that. And also part of what we just talked about here, we go over in a lot of depth in well, first of all, in the fundamentals class, but also in civil, because it's really important to understand how we model these structures as part of our design if we're ever going to get to the point where we can hand our digital design files to a contractor, he can throw them on his bulldozer and go out there and build it. You know, so many engineers won't do that. And they put this little official sounding thing. We can't do that for limits of liability and blah, blah, blah. Well, no, what they mean is we're not sure we did it right. We don't want you finding out. Here you got a paper drawing. It looks okay. So use that. Figure it out yourself.
Or
Well,
hand him the CAD file, let him build it.
yeah. So you're you're forcing somebody to back up and redo work that somebody else has already done. And there's where your errors come in. It's not going to be, and if you hand them something that's correct and they build it, they're not going to, but anyway, I'll be retired before that day ever comes when people are all talking on the same page. But I'm trying to get people closer to it. So
Mhm.
anyway, so we'll come back. So let's come back at about a quarter till, and I'll pause what we're doing and I'll stop the screen share. And then when I'm back, you'll see the screen share come back on. So recording back. So what we'll do next, now that you've sort of seen, you know, and I think you understood, to have that little switch on about flats and all of that. So we'll close this file and we'll open up our data set file. Wow, this thing's not. Going to respond very well off the start page for whatever reason. Let me restart this. Or did it come back finally? Yep, finally came back. Sorry. Wow, I don't know why that's doing that. All right. Okay, so you should have this file handy. And if you'll take a look at a couple of things here, just to get familiar with the file. First, first of all, if you do wind up, um, you know, using, uh, using these 3D orbit techniques and stuff to view the file, and you come back to this top orientation, you'll get it a slightly different rotation than where we started. We're staying in the world coordinate system, but what we've set that up to is on the view menu. We twist screen, just go by line, polyline, or text, and pick one of those little finished floor elevation text indicators.
Yeah.
And that'll put you back to the way, if that'll get you slightly disoriented perhaps. So now, as you can see, what we'll do is we've got, this ditch line down the sides of the road here, down this side. Same thing over here. If we don't break line these ditches out or minimize the flats, you wouldn't get proper flow through those channels, kind of thing. So, we'll show you a couple of techniques on how to add those in pretty quickly. Um, and since you have civil, because it takes civil to be able to do it, because we're going to really draw a 2D line in there first. So a couple of things that I want to look at. If you go ahead and zoom out where you can see everything. Let's go to the inquiry menu and let's use this layer inspector. And let's sort of step through our layers and take a look at what we have. If you look at layer 0, it says it's got, let's isolate. It's got one thing on layer 0. It's supposed to be showing there, so it's probably, I don't know, maybe a undefined block. But here's a layer called areas, and those are just sort of little bounded areas around. These are pond areas. This is the top of a little flattened off hilltop. It's common grade, and just some contours that are in those areas. Depth points should be nothing on it. FFE, that's their finished floor elevations. Proposed center line, proposed grade, 10-foot contours, 2-foot contours. Wow, this thing's really goofy. The AutoCAD version. There's something defined down here, but anyway. So let's see, where were we? There's our contour labels. There's our building pads. It's on a layer called pads. Paving is all of the bounds around the edges of the road, but there's also one here called roads. Okay, and one is really, once we get in and look at it, you see one is actually like the back of curb, and the other one's the face of curb. I think they're both 3D polylines, which really, if I were doing this as a design, these would all be 2D polylines, and I would have a center line alignment. They would all be 2D center lines, but then I would have profiles developed for those, and then I would develop these edges of the curb and the edge of pavement, based on other road design stuff. But we'll just use the 3D work. We're not here to do civil necessarily. And then there's this one called regions, and that's really just the perimeter of the entire area. And again, roads you saw, and some spot elevations. So that's really basically all that's in the drawing. Okay. Make sure I have my restore view on exit checked, and I'm going to exit and come back to the drawing. So we're going to use those layers to help us define our watershed a little bit. Because and what we would typically do here when if we're going to do a storm, and that's really what we'll do is basically the storm network with some structures and pipes and stuff. And I don't think we're going to really have enough time to get into like a lot of hydrograph routing and pond sizing. We might, but we're going to do these structures and the storm system, and we're going to use the rational method doing that because of the size of the site and what we're typically, doing pipe sizing. Whereas we can use two basic approaches with hydro. I'm going to switch to my hydro module now. We basically can do, if we look under our network menu and choose our sewer network settings, and we look under the drainage tab, we can choose basically the rational method or the SCS method. Okay, so those are, a couple of different options, different approaches that we can do with this. So, but what we need to do as we're doing this, we're going to need to come up with these, the C factors to figure out our runoff coefficients for the different types of land cover, right? So,
Yeah.
so in doing that, we're going to use a series of these polylines, and they normally they're closed polylines that we're going to use. They don't have to be closed. They have to be physically closed. Like say this, if I were to isolate, say that one there. You know, it's not, if I look at my property, see, it's not closed by definition, but it is physically closed. It has an enclosed area, and that's really all we need to have, because what's going to happen is when it creates these areas, it's going to essentially do like you would do in CAD, it's going to do a hatch. In fact, we're going to use hatching to display what it's going to isolate out as the area of, say, the pavement. And likewise, if we were to do the roofs, you know, they're going to be like that, okay? So we'll go to watershed, and let's define our watershed layers. And you may have something in here from the last time you ran it. Go ahead and hit clear so that you clear all that out. And we're going to use our rational method right now. And these different methods, notice when I do this, different things become active down at the bottom. When I switch back and forth here. See, I've got a default runoff coefficient, or I've got a default runoff curve number in SCS, whereas in HydroCAD, those go away. But what applies in these different methods are these layer names down here that hold information. Like if, when we're using SES method, we have to consider the soil types. Well, we would have a layer that might have the soil boundaries on it. That would be called soils area. And this is just from the last time I ran it with another project. We don't have those in this drawing. And the rational method, it's going to ignore this down here. But if I'm doing SCS, and if I've got line work here and labels here, like the A, B, C, D type soils, it would pick those up, and it fractures out those other bigger areas based on those soil boundaries, and comes up with those little composite areas that are always such a pain in the butt to try to come up with manually. Now this watershed label is, once it identifies the different watersheds, whether you let the software define it or you draw it in yourself, and if you put the label on a particular layer and the line work on a particular layer, that's what's used in HydroCAD to kick that over into HydroCAD as a starting point to feed it
Well,
all of that data.
well,
Yeah, go ahead.
I'm blowing my nose.
Oh, I'm sorry.
Sorry. I'm paying attention. Just
Okay, so, all right, so we're going to be sticking with rational method, but go ahead and hit clear, and we're going to define the layers that give us the different areas that we're looking for. So let's come down here and say add at the bottom. We're going to add a layer, and it wants us to start identifying these various ground covers by layer. So I'm going to choose the select button for layer, and I'm going to come down here and say find, well, let's just look road. I think roads is the outermost one. It doesn't matter. We could use roads or paving. Either one would be, they're basically the same, just that little sliver of difference. So let's go ahead and just use roads. And now we've identified the layer. We need to identify the ground cover. And if I choose that from my library, or if you've ever, have you ever, have you ever listened to any of the Carlson YouTube videos on hydro?
no.
Well, if you do, and a lot of them are really good. And the ones that Bruce Carlson, the owner of the company, the ones that he does are actually really nicely done. There's another guy there. His name is Mark Long, and he's worked for Carlson 15 years or so. And he does a lot of these things, but he's as country as they come, and it just drives me up the wall. I mean, I'm from the South myself. I grew up in the southwest corner of Virginia, so I got a lot of hillbilly in me. Um, but he says he calls these. He goes, so we're going to go look at our libraries, and it just drives me up the wall. But anyway, this library, this runoff coefficient library, and you see it's pointing to this one called runoff data runoff.dta. And we can set those up in various places, and you can have these defined. This is just the one that comes with the software. You can edit, say, drives and walks. We edit that, and you can give it a particular runoff coefficient. So you can make your own list here. But these are, the typical ones that come out of the drainage manuals from the FHA and like HY8 and all those different the SCS data sets that are defined in their literature. If you load, you could then go out and navigate to find different libraries. Let me see if I switch to my settings. I don't know that I've got any other ones. Yeah, I guess I do. So do we,
Just different states and regulatory bodies have different numbers and
yeah, exactly right. So if I were, say, here in there's Scranton, Pennsylvania. See, that gives me all these different types. Um, now I got to go back and find the one that we have been using. It was called Runoff. Well, let's see. Wonder where I put it. Uh, look at the top of yours up here. Does this still say, is this still pointing to runoff.dta?
uh it's our select runoff coefficient library file to load RCF. I'm not getting a DTA, but I also don't have.
All right, well, let's see. Let me cancel that. Let me go back and add roads. Hit my library. Oh, okay, it reset it. It's in the user. I didn't know where it put it. It's in that user subdirectory.
Okay, yeah, I have that.
Okay, that's what I was just trying to get back to the same one so we can match.
Okay.
So, all right, so what is our type here? We got drives and walks. Uh, do we have roofs, residential, streets, asphaltic? Okay, so that's a 0.82. Now, a lot of places they'll make you use a 90, a 0.9 or something like that. But in any case, we'll just take what's there. So we'll establish that as the runoff coefficient for inside the road would be 0.82. And this hatch layer, and just take the default there or put it on one that you want. And my hatch pattern, I'm going to change that pattern, which is one of these. I'm going to scroll down here and find solid just so the colors will show up better on the screen for you. So I'll come down here, get to the S's and find solid. Say okay, and we'll give it a color. And I'll select, say, this gray color. and we'll say okay. So now I have defined the roads. I'm going to add another one, and I'm going to choose the pads. That's going to be my roofs. I'll give that a ground cover, and I'll look for roofs. There it is, 0.85. And I'm going to make, well, we'll keep those that green color or whatever, something that you can see. And we'll add, let's see what else. You could add, and we'll go ahead and do this. I'm going to select this one called regions, and that's this total outside boundary out here, okay? And I'm going to say that that ground cover is going to be lawns. Let's say it's heavy soil, average slope maybe, or sandy soil. Let's do a sandy soil average. Yeah, let's do a heavy soil, little higher number here. Uh, or maybe, let's come down to residential. Let's do residential multi-units detached. These will be apartment buildings, we'll say.
Without like accounting for like some patios and like other like
Yeah, I
for
mean,
the
basically where we have these covered up with these buildings, it's going to say, well, we don't have, we've got a higher number here because the rain doesn't soak into the ground at that point. It's going to run off and add to our runoff quicker. So I'm going to choose this residential apartment dwelling areas, say okay, and we'll make, now keep those red. No, let's see. It's going to make that this sort of greenish color.
our roofs were 95.
Yeah, that's what it had before. It really doesn't matter. Just something. And we'll say okay to that. Now, oh, I'm sorry. Let's see. That was my read. Let's go to my pads. Instead of that being green, I'm going to make my building pads yellow. So that way it'll be differentiated. Now, the way this works and what we've done so far is we've defined the layers in our drawing that are going to be indicating areas of a consistent ground cover. And, once we've done all this, we would hit our, save. We could save as if we were working on a big project, we wanted to reload it and all that kind of stuff. But once we've defined these, that's going to govern everything that it does in our watershed analysis. So to get an idea while we're here, if you say, select the roads and come down here and say hatch selected, see what it did is it showed you where the roads were. Now, notice what it did because I had these edges on the inside. It did just like a CAD hatch command. It basically, flooded the open space in between that. Now
It did
I'll
mine
clear.
didn't select patch anything. Is that because I'm not selected before I went into the watershed layer command or
If you're in the defined watershed, you have to be in this. Let's say if I go ahead and say okay here. Uh-oh. Uh, let me just put a number in there for now and say okay. And now I can go back to that at any point in the watershed, define watershed layers. And now I'm going to highlight roads. I'm going to select it down here and say hatch the selected.
oh okay. I didn't click on rows or hatch
Yeah.
stuff.
And then I'm going to clear the hatch. But now here's what I wanted to show you. Say this regions. And
Yep,
if I hatch that selected, see how it hatches everything, including the roads and the buildings.
yep.
But what happens, let me clear that. What happens is, let's say hatch all. So what happens is it looks at that overall outside region that we defined as a residential apartment dwellings. with the 0.6, and that actually, I think I'm gonna edit that. I'm gonna select that and edit it. That's not really this apartment dwellings. It should be more lawn. It's the stuff outside of the buildings. The buildings already have the roofs. So I'm gonna call this lawns, heavy soil, average slope.
So the other, like the residential apartment would be like if you're looking at like a really high level like analysis for like a whole town or a county, and you just you knew this area was apartment buildings, this area was more rural, you would select like those for that, and it would just kind of lump it together.
Yeah, possibly, but if I were doing a higher level analysis like that, I'd probably be using the SES method. In which
Okay.
case I would, if I'd switch to that, for instance, and say, add one, and let's select that regions again. And go to see my library is different. I got my soil types.
Yeah.
So that's really, that's more like what you were talking about. But what you would do is here is, let's say instead of these individual roofs, let's say we just had a bounding area around the entire thing. And they said, this is apartment building, you know, Xavier Arms or whatever they called it. And, they didn't really separate out little driveways and stuff. So it is like you're thinking, it's more of a higher level view, but it's not really out to like a county level. Because that would really be done with that different, um, the different method, SCS method. Now,
Okay.
so let's say if I hatch all, you see what it's doing here is, whereas when I hatched the regions, you saw everything was colored in. So
Yeah.
what it's doing is it's looking at this just again, the way the AutoCAD system hatches, and these are interior uh, closed areas. So it goes up to that edge and stops. So when it computes this stuff, it's going to compute based on that. It knows where those edges are and it switches over to the different cover. Now, notice in here, in these spaces inside the roads now, they are now not shown, even though, yeah, and that's because I've got the roads are now active. So they're interrupting this green regions and it no longer picks these up. Okay.
Yeah.
So to be able to get those, we're going to come back here and say add, and that was that layer called areas. And
Oh, like kind of isolated.
yeah, because they're going to be inside. Because what's happening in a hatch command, it hatches from the outside in, and when it hits a boundary, it turns the hatching off, turns it back on, hits a boundary off, back on, off, and it gets into that, this one here, but that's also, this one is interior to this one. And so if I were to go and run the hatch command, you would see there's, let me cancel this a minute. Let me put a number down here for a second. If I were to run the hatch command, let's see here. Is these options here? This is the normal. That's the way it's behaving. See how it's on, then off, then on. If if it were ignore, then it wouldn't stop there. If it was out or once it hit an edge, it turned itself off. So what it's doing is it's not finding these interior islands. It's more like this one. And there's no real way to control that. But when you look at this and you can see, oh, hey, that's not picking those up. It doesn't have anything to find there. But we have these areas like this, and that's on a layer called areas. And that's going to be something that we can define. So if we go back to watershed, define watershed layers, and we add areas, and we also going to set that to our lawns. uh, heavy soil average slope, and we'll make those that same, whatever that color was, I don't know, 92. And now if I hatch all, you see, it picked up those. Okay, so it didn't have this one in here defined. Okay, but that would be what we would normally do is we would put we put that inside edge on a layer that we could then define to pick those up. And so what I would probably do in that case is, let me clear my hatches. I'll say, okay, I would maybe consider doing this. I would select this, and I'm going to copy that one onto, let's make a new layer here. I'm going to go here and make a layer called uh, interior areas. And we'll just give it a little color there. And I'm going to edit, copy to layer. And I'm going to copy this guy, this guy, this guy, and this guy. I think that's all we needed. And we're going to put that on interior areas. And now we'll go back to watershed, define watershed layers. We're going to remove this one, that areas. We're going to add interior areas. And that will be our lawns, heavy soil, average slope. And we'll, yeah, keep that we'll give it a slightly lighter color green here so we can differentiate. We'll say, okay, now we can hatch all. And what the heck? Clear that.
Oh, what the?
Let me find this one. Well, that's what's supposed to be going on.
They're not close.
No, they're close because when I select it and hatch
Oh,
selected, it hatches it up, so it identifies it.
we did copy to layer to areas, and then we made an interior layer. So are
Yeah,
they?
a new layer called interior areas, and then I just said copy to layer, and I grabbed those the edges of the roadway that's closest to the inside and copied those to that layer. Now, I wonder if, excuse me, I wonder if wonder wonder if they've just got a problem with the, I'm going to save this drawing for a minute. I wonder if it's just a display issue. Let me define this. I'm going to save this as watersheds. And let me go and look. Come on. Got something. It's a hard time getting to the files. I think that's a Zoom issue.
Oh,
Oh, okay, here we finally. Um, so when this comes up here in hydro, let's load our watersheds by hatch all. Oops, let's take
oh, oh.
Yeah, so if I clear those, let's say hatch all, clear, select, and it's finding that, but it doesn't do it with that, and it's supposed to. Well, it's not, it's not a version, it's not a version thing or a platform thing. It may just be a display issue.
It's not like that, like the two polylines are right on top of each other.
Well, that might be, but I don't think so because it will composite those. It should. For instance, if I were to say, copy that to like that,
Yeah,
and then if I were to, I don't know why it didn't save that last one. Let me add this back. All right. And if I catch that, it's fine. Clear the hatch all. Ah, yeah, see, and it's really just, so you see what it's doing is it's negating out those areas right there because and that may be why that's causing that problem up here. So, but I think the calculations are honored. I think it's just a display issue. So if I take this, that is a 3D.
these would typically be done with 2D polylines.
Yeah, that's what I'm gonna do. Select that, zero elevation. I'll take that one. And I'll take this one. This one and this one. So they are now there. I'm going to isolate. And let's just offset those. We'll just say, uh, just go half a foot on the inside. And then we'll get rid of these outside ones.
Offsetting a 3D polyline. Is there a special command for that?
Oh, yeah, hold on a second. Let me. Yeah, because it was a 3D polyline. I went to edit 3D to 2D.
Okay.
All right, so now I've got those on there. Now let's see if it, wow, it keeps resetting this for whatever reason. Let's delete that. Add this back to interior areas. Lawn, sand, heavy soil average. Okay, color, whatever. We'll say okay, and I want to say okay. Now if I run it, okay, it's kept it. And if I hatch those, there they are, clear my hatch, hatch all. Yep, that did it. It was the fact that it was touching. But again, I don't think I think the computations honor that okay. Like if you go to fracture that area out, it recognizes it based on that already. It's just this display that's causing the issue. That's interesting.
Because right now if we kept it like this, technically we'd be missing 0.5 times the length of those lines in area. So the
Yeah,
other way would be more correct, but
well, see, it wouldn't find out, what that ground cover is in there. And it would, I don't think it ignores the area because what it does is anything that is not defined up here,
yeah.
if it's not defined, let's say if that one wasn't, let's say we had only these like we had before, but if these were not defined, it comes down here and uses this right here as this
Oh, okay. So
default. And so
yeah,
that was, and you see what's in there now? There's 75, greater than 75% grass cover in good condition. But if I hit set, see, it's not here. It's not in this list, but that was, you can type any of this stuff that you want or pick it from the library. And this was when I had last done it as an SES method, that was what was in there in that library.
yeah.
And I gave it a default condition. So you could then either set or you could just call it, you could just say,
Right. But like the lawns, heavy soil or grass and maybe
yeah,
use a
call it
runoff
that,
coefficient.
good, and give it a number which would be, let's call it a, 0.25, for instance, okay? And once you've defined that, then when you get to reports and stuff, you'll see that show up. I'm going to go back and clear these hatches out, just clear the hatch. So, but because we did this overall outside boundary and we called it here under this lawns, heavy soil average 2 to 7 with a 0.2. So it now has a 0.2, but we would maybe even, we could leave that and that, we could take those completely out and it would fill in the missing areas with whatever we say down here. Okay. Now, and all of these others, the soil, watershed, line works and labels, and the runoff flow line layer, all of those layers here won't have any effect when we're doing this rational method, but they come into play if we're doing SCS. So it can identify if you've drawn in like the time of concentration, the line of maximum flow, flow lines and different things like that. All right, so this is really all we're doing is we're setting up the layers to identify where this stuff is coming from. Okay. So now we say okay to that. Uh, and it keeps resetting. All right, 0.25. We'll say okay. All right. So now when we go to analyze the watershed to help, it's going to help find it. So think about this when you're doing a watershed analysis manually and you go through and you draw the watershed boundaries and you're going to be looking at contour lines and center lines of roads, curb lines, things like that. Um, but we're wanting the program to identify those things for us. And uh, but to be able to do that, it needs to know those elevations. Because it can't figure out where the water goes unless it has a terrain model to follow. Okay.
Well,
So now here's a trick. You can do this two ways. You can go to watershed, define your watershed layers. Now, what we're looking at here, let's say this is a proposed plan. It's got roads, it's got building pads, it's got these finished contours in it, okay? But the contours we're going to use to build the surface model, it's not going to be identifying areas, but our existing conditions are going to be a different terrain model, and then we would not have these roads and these building pads in there. And so you can do two things. You can identify one with just the outside ground cover. Maybe if you've got a stand of trees or different kind of covers, you would identify those and you would save as, and you would call this pre-construction. And then you would go back and do another one with these in it and save as and call that post-construction. Okay. Follow that logic?
yeah. So
But
you can flip back and forth between them by loading and
exactly. But here's a trick that you can use. We've identified our post-construction boundaries. Now, as long as these are just additive, like if we were to take these layers away and that would be our existing conditions, what we can do is leave this as it is and we freeze. I'm going to go here to my freeze by pick and I'm going to freeze off my building pads, my roads, whichever one they were, the interior areas. Okay. And now when I run my watershed analysis, even though I've got this list, if these layers are frozen, it doesn't see them. So it ignores them and it only takes what it sees. Okay, follow that?
yeah.
So, so you don't have, I mean, probably the more robust way to do it is to define this in two different conditions and save and load as you need. But like I said, if you turn those off, you can get the pre-construction analysis versus the post-construction analysis. But again, you'd be using different uh, terrain models because this is going to represent a graded condition. Now, in our case, we don't have existing contours. All we have is this little, you know, pre-built kind of thing that we're going to study. So it's all, all of that stuff's been looked at before, basically at this stage in this development. Um, but we would actually have two different terrain models. In fact, we could do that. We can sort of quasi represent that by doing the same type of thing. So we're going to build two terrain models, an EG and a FG, existing ground and a final ground. And we're going to do that we're going to freeze. So I'm going to go to view and freeze layer by pick, and I'm going to freeze off my building pads in my roads, those interior, I can leave that on there. That's not going to hurt anything there. So this is really going to be my existing ground, and it's going to be crappy, right? Because there's no brake lines, there's nothing in there that's going to give it. And so I'm going to go to my surface and I'm going to triangulate and contour. I'm going to turn off draw contours. I've got some here. I'm not going to look at them and confuse it all. I'm just going to build a surface file. I'm going to write the triangulation file and I'm going to call that just EG. And this time I will turn on to use the inclusion exclusion areas because I have that area defined. And I will minimize flats for what little good it might do me because this is really sparse information. I'll say okay. I'll now select the objects reading the line above, select the inclusion perimeters. There's one. I finished that selection. Any exclusion perimeters or enter for none. I hit enter. Now select the objects. I'll grab everything here. Off I go. And so now I've built this one surface. And if I look at that surface, you can see that it's, well, those are the contours that it thinks it has. Let's put that up to 2 to match what we've got. So, you know, relatively the same, but you can see, and even the roads are there, but not, you know, you don't have those nice edges on the roads and things like that. You do at least get the ditches defined. So, you know, that might be the surface that we would use. Then we're going to turn on, I'll go to view and say restore layers. Oh no, I didn't isolate. I had to go to view thaw layers. And now if I triangulate and contour again, this time I'm going to make a file called FG. Just go through the same thing. I'll pick my inclusion, no exclusions, grab all my data. And off it goes. And now when I look at that surface,
I'm just like a step or two behind.
okay, let me turn that off a minute. And
But,
all right, so what I did you get your existing ground built?
yep, no, I got the, yeah, I was,
And then I thawed back those layers that I froze.
yeah, I rethought those,
And then I went back to
wrote
sort of
a, I
triangulate.
do, PR, okay, selected,
So when I triangulate and contour, I changed the file name now to FG.
okay, yep, I just built the new surface. I was just like 10 seconds behind you.
Okay. So, but
Not that I'm
all I was going to show you is that when I view that surface now, you can see now I've incorporated the buildings and the road edges are nicely defined. You can see the curb lines and such. But now, if you may notice, I mean, that's a really crappy surface, right? Because those buildings don't have those skirts on them and things like that. And now, if you were to now look at this roadway down here, for instance, you see all these sort of choppy looking things. Even though I said to minimize flats, that didn't work very nicely. This one did up here. You see this ditch on the side of the road and this ditch, it honored that pretty well. It didn't really up in here. I've got some stair steppy looking things in there.
Mm, Um, select my I'm in the 3D surface viewer, same as you.
Uh,
Um,
oh, you know,
it
I
being
one thing I forgot to go over, Fred, and maybe this is part of an issue. Do you use this viewer much?
this is my first time using it.
Oh,
Like rotating and looking around, it's
yeah.
not really
I was gonna say you need to know how to do this stuff. right? So let's do a real quick tour of that. All
Like
right.
it wants to let me, I can like tilt the vertical angle of it, but it's not letting me like turn to the side or dynamically kind of look around.
Exactly. So here's the trick to all of that. I'm sorry. I'm just I was assuming that you used this before and knew how to do it. Um,
That's okay. It's sometimes works and sometimes it doesn't. I don't
yeah.
know.
So here's the trick. First of all, over here in the controls, under View Control tab at the top,
Yeah.
tabs, come down here and make sure this middle, this Y axis, rotation axis, make sure that's locked.
Okay.
Okay. Now um, the key icon up here that you want is like this panning and zooming, all those kind of things you can do with the wheel, just like you do in the regular CAD system. This button here that looks like a fishnet looking thing, that just toggles on and off whether you see solids colored in or only their edges. Okay. And when you're looking at it, excuse me, you're looking at a surface file, it loads up the triangles and creates them as solids. Okay. So you're looking at 3D faces. And so that's why you can see that as solid. And that's just a toggle. Okay. And, but the icon that you want, the one that does all the work, is this one that looks like that three color cube and the little circle around it. That is your rotation mode icon.
Yeah.
It works like this. Notice when I'm out here away from the data, you see the shape of it. It says Z and it's got a curve arrow.
Yeah.
But when I get over the data or close to it, it's not exact. It switches to X and Y. Okay.
Yeah.
It's up and down and left and right. It does that same thing. So when you're over the data, it's X and Y. When you're away from it, it's Z. But here's the trick to be able to look anywhere you want to look. So let's suppose I want to look down, say, this street line right here, right? So the trick is I make sure I use that icon, the rotation icon, and you're going to pretend that you're standing in your driveway and you're looking at your house and all this data that you're looking at, that's your garage door, right? And what you want to do is you want to raise your garage door up, almost all the way up. You're going to get it, you know, nearly flat, but somewhat, oblique. And you do that by moving the cursor over the data to where it's X and Y. And then you come down like toward the bottom of it, making sure it stays X and Y, and you click and hold the left mouse button and you push up. Now notice because we've locked that Y axis over on the right, if I go left and right, it doesn't rotate because
Yeah.
it's locked. So what I want to do is I'm going to, and I've had to get another bite. I just let the mouse button up and go back and get another bite. And I'm going to raise it up to be sort of oblique like this. Then I'm going to let the mouse button up and I'm going to come down to the bottom now. And when I click here and I go left and right, it spins around that Z axis. So it's only working on the Z axis. This works on the X and Y. This works on the Z. So we're going to, whenever you first start out in plan view, you're going to roll it up no matter where you're wanting to look. Now, remember, we're going to look down this road over here. So I'm going to lay it back like this, and then I'm going to come down to the bottom and I'm going to line up where I want to look. And then I'm going to point to it and just use the wheel on the mouse and zoom into it. Okay. So if I want to look at, say, the pond over in that, let's say I want to look at this. Well, no, let's look up at this road up here in this other area. Well, you can just zoom out and then, line yourself up and then zoom back in. You just keep it, you know, laid back and you can do little adjustments. And that kind of action will become very, very second nature to you very quickly. Okay, so you see there's still some really kind of crappy looking surface models. And you see, it's sort of hard to do anything here when you're all zoomed in. So just roll back out, do a little tweaking, rearranging where you're looking. And now let's look down, say at this little pond, zoom back, that kind of thing. If you just remember that and just pretend you're standing out in your driveway, you're looking at your garage door, just open it up, almost up, spin it around, line up, and then zoom in. And you can press and hold the wheel and pan just like you do in the CAD system. Okay, so that's all there is to it.
Okay. Yeah. Okay.
So it
I was
becomes
having trouble panning around, and the
helpful.
Z thing was really good. That was really helpful.
Yeah, I'm sorry. I just assumed you were using a law. So
That's
good,
all right. No,
good. All right. So that's a couple of things that we saw a bunch of let's look at this area right in here, for instance. Again, I'll pop that up and look at that. And I'm going to zoom up here, roll it around and zoom in right in there. And you see I've got all those stair-steppy looking things around here. Well, how would you fix that normally? We put a break line down the nose of those contours, right? Even though we did say minimize flats, but so here's what you would normally do. I'm going to make another layer, and I'm just going to call this one VKLN, and let's make it cyan, and we'll make it current. All right, so now the easiest thing to do, and they do this a number of ways. You could draw a 3D polyline, snap to that corner, put in an arc, have it interpolate the elevations until you hit this elevation. So you're all the time switching in and out, but it's easier if you draw in a 2D polyline and then adjust that 2D for shape, and then you're going to elevate it based on it crossing these known contour elevations. Okay. So we're going to do that with our draw 2D polyline command, and you could just use standard P line or whatever. But I like Carlson's tools really well because they let you use point numbers. And I'm going to come down here and say use the current drawing properties because I'm sitting on my break lines layer. I'm going to say okay. Now I have a running object snap set for endpoint as well as a couple of others, but I'm going to grab the nose of that contour and I'm just going to come down here and grab all of these contour noses, just straight one to the other. Now I know what you're thinking, but we're going to fix it. So we're going to come down here and just grab all of these little endpoints. And now we've got this, but we didn't really, that's not really how it works up in here. So I'm going to highlight that line, select it. And in this midpoint grip, I'm going to hover the mouse and convert to arc. And I'm just going to reshape this as I need. These are okay down here, maybe down here. I'm going to convert
eyeball it.
to an arc. Okay. So now I've got that. And then maybe the next one I might want, I'm going to go back here and say repeat 2D polyline. I'm going to pick up these edges. And that should work. And I'll do the same thing right here. I'm going to convert that to an arc. And maybe I'm going to type C to continue this one. And I'll go up here and maybe catch that. I should have started there. And I'll shape that up like that. So, you would do these things, just working your way around. Now, we're not going to do that. We're not here to try to fix this really poor drawing example, but that would be what you would do. I might put one, say, here because we're going to use this area here. So I'm doing the same thing over on this end.
Start at third, fourth, okay.
And I think if we go down to here, we're probably okay enough to do there because the minimized flats worked okay for the most part there.
Oh, how far down did you go?
Just down to there.
Okay.
We're not going to worry too terribly much about it.
Yeah, we don't have to do we're not doing the whole drawing, we're just teaching, right?
Yeah, and I would probably maybe do that. And, nothing critical. So, so we've added these now, but now if I go back and rebuild the surface, they're going to get ignored, right? Because when I try to build this, or I'm sorry, when I try to triangulate and contour, I have on my switch to ignore zeros, and now they're just 2D polylines.
Yep.
How do we make them 3D? Well, we switch to civil. We go to our 3D data menu, 2D to 3D by screen entities.
Three 3D data
Yep. And then there's a 2D to 3D.
by screen entity. Nor zero. Extrapolate elevations.
And if you wanted to keep the 2D and put them on a different layer name, you could, but we don't need to. We're going to just say that's okay. We'll say okay, and we're going to pick the ones we want to convert. So that
What's
was
like a good intersection extend tolerance?
just 0.1.
Point one.
It's whether or not it actually hits, and these all do, so it's not going to have any effect. Now, I would also, have built these ditches down here as well, but they came out pretty nicely in our model. So I've added those three. I hit enter. It now wants me to pick. And so I'm just going to do a crossing to make sure I get everything that it could possibly intersect. And I'll hit enter. And it says converted 3 polylines from 37 intersections. Now,
So sorry, so I picked the three,
mhm,
hit enter, and then it says select surface 3D faces, lines and polylines,
right.
window everything.
That's where you could type all, you could select all your data or just get enough to where you get all of those contour lines that they're going to intersect.
Yep,
Okay.
and then enter.
Yep. All right. So now the easiest way, and this is the way I do my surfaces. When I find a problem with the surface, I go back and fix the data and I recreate the surface. You just as easily could have gone to the surface menu and said, here, the surface manager, and then you would say add break lines. And that does sort of a real-time edit, just like you could do it in the surface viewer. You can add break lines and do all that, but that's sort of tedious. I'm going to have the same effect of having added these break lines if I just rebuild the surface. So I'm going to go back to surface, and I can do it here from civil, if I can find my surface menu, and choose triangulate and contour. We'll keep the same file, that FG. It's going to prompt me to overwrite. Yes, it's okay. I'll select my interior. There's no other interiors. There's no exteriors. Now select the points and data to triangulate. Just grab it all again. This time it's going to get those lines that we just made. And then when we view surface file viewer, our FG, and we stand in front of our garage door, we push it up, spin it around. And we zoom in there and we take a look at that. See now all those little stair steps that used to be over here are now gone. See, they're on the other side, but not on this side.
Yep.
And same thing is, and that's why I didn't follow this all the way down, because minimized flats took care of a lot of that until you get down here. And this road, we should have probably done that in there. But again, the class, we don't have enough time to fix this problem file. We would normally do that. I would take these out, by adding that data in there that I needed. But you see the effect, and that's what you would normally do. See, these would over in here, that never got minimized like it should have. So I would have normally put these ditch edges in over here as well. But again, I'm not going to worry about that so much, because we're basically going to be draining the roads and catching that, and but you would normally do that to try to get it now. So we now have a surface called our FG that we can use to do this um, watershed analysis. And so let's take a real quick look at that, and then we'll have our lunch break here in a minute. So let's go back to hydro. And let's go to our watershed menu. And now we choose watershed analysis. And notice the first thing it asks us for is a surface file, surface model. And we'll use that FG. And we'll open that. And we get this little guy loads up over here, this docked control box. Now, see, this is something the IntelliCAD version does not do. I don't know if yours does it or not, but you see how the
What command? Sorry.
the watershed analysis.
Watershed analysis. Gotcha.
Mhm.
And PR. Yep. Okay, I'm
So
in.
that you get that docked dialog. Now, the IntelliCAD version doesn't do this. I'm noticing though AutoCAD does. You see how it sort of squashes things on the plan view? You look at the little
Yeah, it's kind of compressed.
yeah, the orbit circle is no longer a circle, it's oval, and everything's sort of squished.
Yep,
I don't know if yours does that or not, but
it does.
yeah, the IntelliCAD version doesn't do that.
Hmm.
And it's just a visual thing, so I wouldn't worry about it. But now what do we have in here are a whole bunch of controls that we can use to come up with our watershed. Now, down below here is where we put in a rainfall depth. And that's going to be we'll see the different effects of it. So if we have a rainfall depth, a very tiny rainfall depth, and let's uncheck these up here and let's just draw these sink locations. Now down in here are, we'll go ahead and group our watershed index, but these settings button, this is where you can set, what layers things get drawn on, what symbols get used. And this filter settings, if you go to that tab, do you have values in here?
They're all 0.
Okay. Those are for if you allow spillover, it looks for a minimum drainage area. And if you have a drainage area that's smaller than whatever you set here, it's going to incorporate it into a larger area so it doesn't fracture out the subcatchment so small. Same thing with the amount of storage volume, whether or not it identifies a sink location. And it's a storage volume and a drainage volume, as well as how it so it won't make a little teeny tiny sub watershed. If you give it a minimum volume, it has to reach that before it identifies as a separate watershed. Um, different structures, different symbols. We're just going to leave these all as the default for right now. Now go to your overflow control. Do you have numbers in here?
No.
Are they all zeros?
Yeah.
And I wonder, because I've played with mine, I don't know. I just want to match the same things that we see on the screen here. I wonder, we'll take a look at what it looks like here. So now, back in our controls, if we turn on only this sink location, and let's put in a waterfall or a rainfall depth of 1 inch. And you see down here, it says higher rainfalls for 2 inches or higher. So it will join any spillover watersheds together into a larger watershed. Use a low rainfall, for example, 1/10 of an inch, to detect more low points. So if I say now draw, you see down below on the command line, you see all this stuff happening. It's reading the surface and it's looking for low points in the model, and there it found them all. Okay, because they had a relatively small rainfall depth. And you can see, for
Oh,
instance,
hold on. Oh, I'm sorry. And it's just my layer properties box just went haywire.
oh,
Okay, I'm back.
yeah, okay. So
It
now,
covered up the other settings.
if you zoom in down here to say this lower
Uh,
left, you see those two low points? It identified there's already a marker there that says low point 371.3, and that's at the crown of the road. Well, over on the edge of pavement, that's even a little bit lower than that. So it found those as those particular low points. Okay, so now let's go back and hit this little undo button right next to the draw button so it clears those out. And let's go back into settings and let's look at overflow control. And let's see, let's put a maximum pond volume to merge in cubic feet. Let's say 1,000. A minimum pond volume to separate, let's say 100, and a minimum pond depth in feet. Let's say it's got to be at least 6 inches deep before it considers it a pond. And let's go ahead and turn on allow overflow at the surface boundary. I'll say okay. And now let's hit the draw button again, and it should be fewer. We'll see. So there you see we've got it, it found the low spots around the edges where it would spill over onto the adjacent properties. But it found this low spot right in here and right in here, but it no longer found this as a low point in that particular localized area. Now, if we were to come back to our controls, clear those, and let's set this to say 0.01 as a rainfall depth, and then draw them again, it may identify back in the roadway. We'll see. I'm going to say it's, yeah, so it found one of those two low spots, and it found this one here in that pond, found this one in this pond. So it's, you see the effect of this rainfall depth on what we're doing.
Yep.
The lower the rainfall, the more sensitive it is to finding those localized areas. Now, I'm going to go back to settings now. I cleared my draw. I went back to settings, and I'm going to go to my overflow control, and let's up these numbers a little bit here. Let's see, minimum pond volume to separate. Let's make that 10 instead of 100. Let's make that maximum of 10,000. Minimum pond depth, let's say, is, oh, 2/10, so that way it'll catch the curb a little better. Say okay, and I'm going to draw those, and let's see if I get both of those at the roadway now. There we go. So now I get these in here. It picked up the low spots along the road. Here's in this pond, up here in this pond, that pond, this pond, there's a pond down here. This little localized depression was something that you would probably, put a culvert to drain it out into the ditch. Um, or actually, you would do a better job on your graded contours is what you would do. Uh, so, so now that shows you where those low spots are. But what does that also mean? So if we'll go ahead and leave those on, but let's go up here and say, check on to draw our watershed perimeters, and we'll fill those watershed areas. And turn on our pond areas. And now let's just hit draw. And it's going to reanalyze, and it's going to find all of these little localized subcatchments. And you can see I've got one big one here. Say this, you know, I can't, until I get out of it, I can't select it. Let me exit that. And so now if I see this area, it's a pretty good size subcatchment, but that's where, everything that range within that is all going to come down to, say, that low spot down here. I've got this one up here. Okay, so it's identified those. Now I'm going to go back to my watershed analysis again, tell it to file again. I'm going to clear the draw so that it clears that stuff out, except it's not going to do that like it used to. All right, I'll exit that. Now I'm going to find that layer that's on, which is layer watershed fill. So I'm going to erase by layer, edit, erase by layer. I'll select from the screen. I'll pick one of those, and I'm going to pick my low spots. And I'm going to pick one of these boundary lines too. And see, that's my watershed perimeter, watershed sink, watershed fill. Say okay. And now I'm back to my drawing. So I'm going to come back to my watershed analysis yet again, give it the surface. And let's say I'm going to ungroup these. I'm going to unfill my watershed areas. And I will do my sinks and my pond areas. And let's draw those. I didn't see the ponds being drawn. Oh, I know why. So this is going to analyze the surface. And it didn't draw any ponded areas. Now, why do you think that might be? I've got the low points.
I didn't even draw the perimeters.
Did you if you uncheck that, that's fine. And I'll clear that, but we don't need to draw the watershed perimeters. Let's just look at the ponds right now. I've got
Okay.
I want to show the pond areas. But why didn't I see any areas drawn around the ponds, do you think?
Um,
This is just a logic question. It's not a CAD knowledge question.
didn't draw.
Look right here. It didn't rain very much, did it?
Oh, so like
So if we
these are
had,
pretty big
if we
detention
had like a,
basins.
yeah, if you have like a 5-inch rainfall
Yeah.
and now hit draw,
when you change settings and you hit draw again, it overwrites the previous
Uh,
drawn stuff,
good question.
or do you have to hit the undo?
I'm not sure, to be honest with you. Let's try it and see. Let's see when this finishes up here, which you can
Mine
see,
didn't even. Hmm.
we should see our ponded areas.
Oh, okay, it just made it. There we go.
There we go. So now you see the ponded areas. So you see you've got low spots in the road.
So if you have 5 inches of rain over this area,
Yeah.
does this account for like the runoff coefficients and stuff that we did in the previous exercise?
Yes. Yeah, it's analyzing all of that as well. But right now we're not getting things like these flow lines here that really show us that, and we're not getting uh we can identify this runoff tracking and these watersheds above. So if we were to report, say, our watersheds, you could get these, the rain volumes, blah, blah, blah. We don't, this is more, this is more flow. So it's not really, there's really nothing to account for in terms of the land cover. Um, it's just accumulating the water at the low point with that much rainfall, and it accumulates the slope of the terrain, but it assumes that that water runs down into there. So as far as infiltration and all that, I do not think it's doing that at this level, at this particular tool. It might, but I don't think so. Let me.
Well, I meant like, cause isn't it, cause, so this is if you had 5 inches of rain over this on the site, and then you looked and there was no infiltration, no,
If,
catch basins or anything that's
if
moving it
you,
around.
yeah,
It
if
would
you,
just collect in these low spots.
yeah, if you accumulated these areas and figured out the volume of water that's within these boundaries, I don't know whether it has extracted the infiltration out. I don't think so. I think it assumes total runoff.
Oh, okay. I mean,
But those runoff values, those areas that we did, it's not to abstract out the flow, it's to compute the time that it takes for the flow to travel. That's what those runoff coefficients are doing.
okay.
Okay, so it's assuming the ground is already saturated and now everything is all runoff. It's just how quickly it runs off. All right.
All right.
Now, to answer that question, let's go back to, say, a 1 inch rain instead of a 5 inch, and let me hit draw and see if it clears it. I'm not sure that it does, but we'll find that out. Yep, apparently it does. It clears it and redraws.
Oh,
Come on, think your way through here. There we go. So, yeah, I can see this one's smaller. That one's a little fractured looking. Um, but I'll put that back to a 5 inch rain, which is more realistic for what we're looking at. Um, and if we fill those areas and get our perimeters, Draw this one up again, and then we'll use that as our picking up point. So yeah, now the pond areas are going to be superimposed over our subcatchments. And now if you look at, you see this sort of fractured looking line that goes through my roof area here. Well, that's not realistic. You know, that all that's doing is reading triangles. And this is such a crappy surface model. You know, normally, see, if this had a peaked roof on it, for instance, you know, half the water would run one side, half the other side, you know, so you could use this to get yourself some boundaries and then go through and manually draw those boundaries a little better, um,
Yeah.
you know, to help you come up with those. But the flow numbers and things like that are going to compute pretty much the same um, as you've picked this up. Now, if let's go, I'm going to go back to, let's see if I can do this, erase by layer. I may have just locked everything up. Let me let me clear those and then exit. Now, so now what, one other tool to show you there in this watershed analysis, or another set of tools, is you can look at watershed, say above a point or above a line, runoff tracking, that sort of stuff. So if I say watershed above a point, I'm going to click that. And now I'm going to it's going to read the surface. And now watch the command line. It's going to tell you to identify a point. And as they pick an origin point for the watershed evaluation, it's really not really an origin, but a destination. So if I look at, you know, let's say I've got an inlet that's right in here. So if I pick that point there, it draws, you see that boundary? That's what feeds to that point. You see how it followed the crown of the road?
Yeah.
Nothing from the other side of the road came into it until you get up here. It actually spilled over the crown because it's coming downhill faster this way than it would be to try to wrap around it. So that identifies that little contributing area for there. And now notice down at the command line, it's still asking for points. So let's say if I picked a point in here, or I picked another point over here, a little tiny one. If I picked a point there, for instance, let's pick down here in this pond. Let's see down here to that roadway there. So everything here comes from the high point and it wraps itself around and falls into the low point here. And if I pick a point in here, for instance, and it flowed around this way. So it's identifying, now this is putting watershed boundaries in. So I'm going to hit enter to finish that command. And you can also do, say, a watershed above a line. And when you do that, for instance, you're going to pick, now notice as I track my mouse, I get all of those identifying things, the average slope, current elevation, the area above a point, and all that, but it wants me to pick a point on one bank of the stream. So if I'm interested in what comes down to this, to the end of this road, say crossing this road. So if I go from here over to here, pick a second point, it's now going to draw that. Now I'm going to exit this so I can isolate. I'm going to get rid of these other ones. So you can see what it just did. Let's get rid of this one and this one. So now this guy, when I crossed the road here, that's the area that's going to drain to that line across that road. So it's just another little analysis tool. So let me clear by erase by layer again. So so those are a couple of things that you can do. Now you're going to see that that type of analysis of flow into a particular point when we get into the structures, when we start to put our inlets and pipes in, you're going to be able to click a point and it's going to actually draw it a little nicer. It's going to crosshatch it, so you're going to see it a little nicer than that. But we go to that watershed analysis, give it that again. And one last tool to look at, and then we'll break for lunch, is this runoff tracking. And when we do a runoff tracking, let's go to analyze the surface. And I'm going to do, you can either pick individually where you can pick a point and it'll trace the water, but I'm going to do a major flow by area, all surface. No, let's do it like so. Major flow by area, 1,000, cut off above. We'll say okay. And so now there, you see all these lines. Let me exit that. These are the major flows into, see that low point? See, so those are like your lines that goes down into that low point, that comes into that low point, that also feeds into that low point. This one here also feeds. So you see it's done basically one of those is going to be your, um, what you would use for your time of concentration. You would find the longest one that you would use or put all those paths together. There's other ways of doing the times of concentration, but this at least shows you where this water is going to flow. And you can use these once they're in there to say, here you see that contour line. So this is in that ditch along the side of the road. So you see how the water flows down that ditch.
Yeah.
But you're up in here and you see normally you would see it flow down this ditch, but we didn't model that. So those stair-steppy things didn't happen. So here the water hit a flat spot and kicked out to the curb and it flowed down the inside of that curb line. And it didn't find that well-defined ditch until it got down here and the minimized flats took care of that. Okay, but whereas up here, it went down to the ditch, but it filled the ditch and jumped the curb and came down the road. Let's see, where's another example? Well, if we had defined the ditches a little further, you would see that. So this, for instance, came down or got into the road, but the curbs contained it. I don't see anything coming down this ditch line here, so that's really not all that deep a ditch. Or there's not a whole lot that contributes there. What falls and would normally come down that ditch is actually jump the curb right in here, right there,
Mhm.
and then follow down there, okay? So I'm going to erase by layer again. I'll hit clear, pick this from the screen just to get the flow line. And say, okay, and that's going to clear that. I'm going to hit save. And we're about a half hour late getting our lunch break, but you're going to get your whole hour. So we're not going to come back at 1. We'll come back at 1:30. And but we'll pick up from there. We'll show you some of we'll run through some of these others because you've got these other things like watershed by grid, but we've got let's see. We want to talk about some flow tracking. So runoff tracking, that's basically that same thing. We'll give it that surface, and there's that same dialog box that you saw. And if you pick individually, for instance, you say, okay, what you could have done from inside the other thing that we had, it's going to read our surface. And we're gonna come down here and let's say, well, I'm gonna put a yard drain right in there. So if I pick that, or I'm sorry, I did it backwards. I said, if it rains at that spot, it's gonna come down here. Wow, jumped the curb, came back around, went back around that way because of the, and then it went all the way down and around and came into that low point. Okay. So, just a number of tools that we can use to help verify what we've done. And again, it's such a poor surface model, but sometimes that's really all we have to work with. And you'll see how when we start to put our pipe networks in, how that's going to, it's everything flows nicely inside the road. So that part's been modeled pretty tight, but all this other is a little odd out there. But we'll pick that up. We'll look at the libraries and the rainfalls and how to find out what those are and how those go into our calculations when we come back. All right.
Okay. I I mean, I don't need an hour to take lunch. Obviously, if you are, then no.
Yeah, I typically do because I'm gonna have to work through it because again, I do consulting practice as well. So
Yep.
I'm
No,
gonna
I
have,
throwing it out there.
yeah, I
Okay.
would yeah, I'd be glad to work right through it with you, but I've got to catch up on a couple of emails and things like that that I've let go.
Okay.
So let me
Sounds
come back to that. So I will pause our recording. Okay, so turn our recording back on and we will pick up where we left off here and talk about a couple other things that we can do. Uh, First of all, we can take a peek at some of these little, uh, sort of look at the way the module is organized. We've got the surface menu, which is just a sort of a subset of surface that you're used to seeing under civil, for instance, and it's got three commands at the top to do gridding, three down here that do triangulation, and then some analysis type things. And then this universal soil loss is basically um, it'll calculate based on let's just call it say grass, soil erodibility, cover factor, practice factor, a- acres, and select an area. And then if we use our surface, select it by perimeter, let's grab, say that area, it identifies it, gives us a slope length less than 1,000, like 2 feet, 16%. And gross erosion for the area, tons per acre year, calculate the universal soil loss. It then goes through and finds this number that is using universal soil loss equations. It just helps to analyze the drawing based on our identified boundaries here. And you can see about that in the help system here. Calculates the volume of sediment that you expect from a watershed by erosion.
Oh,
Okay. So it's a command that a lot of people miss out on seeing. Um, they don't really know that it's down there. But it has to do with the surface analysis itself. And you've got other things like the slope zone, slope report, slope at different points. So if you're wanting to look at the slope of the surface, let's say I want to pick on the surface, whether we draw it, let's create a report between 2 points in percent downhill. So if we go from our surface from say here to here, you see our little indicator here in our box. It's telling you, what's that slope along here. It gave us generalized from the two that we picked. And it actually shows you the slope of the triangle that you're sitting over is what it's looking at. So if I go from here, say to here, you get a sense of what those are. Now you can look at a little report. You can do the first elevation, second elevation, percent ratio. And it just shows you what those were. That was the 7%. There's the 5.8. That's 14.3, excuse me, 14.3 to 1, 17.3 to 1 as a ratio. And then we will get rid of those. But these others now, do you understand these differences, the grid files and the triangulation files?
I've not used grid files.
Yeah, and you probably won't much at all. But gridding is something that you might use, again, back to that multi-county type study. And it usually just analyzes the surface based on a regularly spaced grid of points, which you might get what's called DEM data from the USGS. That's a digital elevation model. And what that is, it's a lot coarser than say triangulation, which puts in break lines and recognizes curbs and such like that. But a grid file, you would give it, say, a lower left corner and upper right corner across a big area, tell it the spacing you want for the grid intersections, and it just samples that surface at all those points. And it's a very sort of coarse sample of the surface, but it's representative enough to do those larger type studies. And they compute faster, although, see, computers are a lot faster nowadays, so triangulation is almost universally used. So I wouldn't worry too much about it, but it's there if you ever need it. And then your triangulation file utilities. Now you can draw the triangles if you like. There's no real point in doing that necessarily. But your triangulation file utilities is a way to do something like if you load a base file,
Oh,
say we load up our existing ground.
yeah.
Do you use this one much? Have you used it?
Um, I've used yeah, and again, I'm not like a don't have a lot of I don't have I have minimal training on a lot of this stuff,
Right.
but I
But
use this the surface utilities to merge, like if I have like a proposed road, merge it to
exactly.
the existing,
Yep.
and or
Like,
like I'll pick a bounding polyline, I'll get like the average grade, like pin statistics,
mhm.
um, things like that.
Yeah, and really the biggest thing that you would do here is this say merge. Like if you designed a building pad or something that you would um, you know, put, let's say you just designed a pond and you wanted to cut that into this ground. And then when you come down here and do this save as, you can call this a new merged surface. That's the big one, this merge 10. So we won't spend any time on that. I just wanted to make sure you see that that's there. Now that's, all of those tools are available, say under civil, which is probably where you'd be doing most of that type of work. Um, Elevation zone analysis and slope analysis, those types of things are basically the zone analysis. If you looked at a surface file and you would put in, say, ranges, let's see if we automatically say starting one set value. Let's go say every 5 feet. And let's see here, center colors, set gradients. No, let's just say center starting color 1. All right, so then it would do something like this every 0 to 5 feet, 5 to 10, 10 to 15. And that goes all the way up to 410. So we would probably come down here and take a bunch of these out. Let's see. Well, it should do that. We say okay, and then we look at our surface. And that gives us, from these particular zones at these elevation ranges, and that gives us an average elevation, minimum, maximum, number of acres, etc. You can report, save that on there. Now, that's basically just analyzing, giving you the numbers, but over in civil or even or in survey, either one, if you draw the contours, now you don't have the draw commands here, but over in civil, for instance, if you say contour from a TIN file, and I'll just show you where that is. Here is under the contouring, is if you were to draw these, you see this hatch zones.
Yeah.
What that does is, I think this will be quick enough to show you. Here's that same thing that we just had computed as our range. It's going to color in, and then we put a little legend over here, and show you the range of colors and the way it would fill out, the things. Obviously, we're a little bit skewed with our bad surface here, but anyway, it basically shows a what's called a chloropath or chloropleth. I forget what it's called. But then let's erase these by layers. Oh, let's see. Let's select layers by name. How many zones? It only identified here. Let's see, zone 1. We'll get all of these. Too many layers selected. All right, so we'll do it. See if we can get that many. Oh, sorry. They still haven't got them all, I don't think. Let me see. We'll get all the hatches. Yep. And we'll do one last time here. Select these drawn contours. Although we got the roadway contours drawn in there this time based on the 3D lines that it read. And now we're back to those. All right, so just some analysis tools there under surface. Now we had, let's see, back to hydro. So now the main things are this watershed menu where we've been looking at some of that, some runoff tracking and different analysis there for the watersheds, and network. That's where we're going to do a lot of our pipe designs and things like that as well. The structure menu is more for like a well, you've got your ponds and your outlets and things there, and your channel designs, culvert designs, and these are more sort of like one-off type little individual things, whereas the network would do the network of multiple pipes, and these are more your little one-off design tools. And then HydroNet is where you can switch in and out of using the HydroNet Explorer also sort of accumulates the different data. We'll look at that in a minute here. And that also helps
Oh,
pick,
sorry.
I'm sorry, did you ask a question?
Oh, I was just coughing.
Oh, again, sorry.
Coughing my brains out.
Yeah,
Sorry
sorry
about
about
that.
So this HydroNet Explorer then is going to be a little docked interface on the side, and we're going to use that to sort of gather up the various components and do the analysis, and then also to feed that into HydroCAD. Now that's all based on this define watershed, if you're using this and it pulls these layers down here, and it gets all that data ready to switch in and out of HydroCAD. So
Awesome.
that's what that one does. It's just sort of a little tool set that sort of encapsulates a lot of these commands all into a single little interface. Okay. So let's now take a look at some of these settings that we're going to be looking at. And we've got some the sewer network settings we looked at earlier, where we've got whether you're doing a storm sewer or a sanitary or a utility network like a water line. Sanitary will still flow by gravity, whereas a utility network would be like a pressure line system. And then under design is whether you design downstream to upstream or upstream to downstream. And you tell it in here different ways that you want to automate the design to where it's going to find minimum pipe sizes, automatically analyze the watersheds, or just take the numbers that you feed it instead. Your drainage methodologies, and then you got various things here like how much minimum and maximum cover over your pipes and manholes, your velocities, your slopes. And again, you can choose to pick from the library, a maximum spacing between structure, between manholes or inlets. Step up if you have any drop manholes, etc. Drop across a junction, like usually a tenth of a foot, typically, whether you're matching crowns or inverts, etc., etc. You can set a percent of your targeted flow depth. That's usually set to like 80% full, so a 0.8 factor. Size the pipe at the target depth flow, and that sort of thing. Laterals are basically, these allow you to, once you have a pipe network in with the main pipes, then you can go and design your laterals off to your different service connections. And it sets those in at slope. And then as those mains might change their slopes and depths, it pulls those laterals and things down with it, keeps it all connected together in a network. Error checking, you can check collisions with another sewer network while you're designing, or you can wait and do that as a separate command, which is what we typically do. And that's like if you got a storm system and water lines and sanitary lines, you have like 3 different networks going, and then you can have it check for collisions. And then you've got your displays and preferences here, like how many decimals. And then the coordinates when pick structure locations show the drainage area perimeter at structure locations. Highlight the current pipe or lateral. You select one, whether it thickens. And you'll see that when we get into the docked controls, when we select a pipe, you'll see it thicken up in the drawing, so you know which one you're looking at. the sewer pipe length as it's calculated. Here's an example of center to center. It's 100 feet center to center, but if you're using center to center piping, it calls that 100 linear feet at 2%, which is 100.02 slope distance. Or if you're using the actual pipe, it takes the size of the structure. This is a 4-foot diameter structure. So it takes off that 2 feet and that 2 feet. So that becomes a 96 linear feet at that slope, which is 96.02 feet. That's the way it would calculate if you go actual pipe length versus center to center. And what that controls is when you're drawing your pipe profiles and such, is it labels the pipe and says how many linear feet of pipe. It's however you want to see that. Okay.
So you want an actual pipe would be better because like a contractor looking at it, he's like, okay, I got 96 feet of pipe versus,
Ex exactly right. And you might, if you're going for that, you would want to use your slope distance and your actual pipe length.
and then, but if you're doing center to center, it's horizontal.
No, center to center, you can still do slope distance, but
Okay,
you would typically see a lot of agencies require, when you say so many linear feet at a particular slope, they're talking about a horizontal distance, but at a slope, which makes it longer. And it just depends on what the agencies that that's approving the designs might require. And you generally have, just match what they're going to ask for.
okay.
Um, and then the sewer pipe slope, again, that's for the length, and then for the slope, either the actual lengths or the center to center. We typically go structure to structure to calculate those. But if you say actual pipe length for the slope, it's going to, like if you have a drop, if you're coming in with like a 1/10 of a foot drop across a structure, instead of going center to center, it goes out to this edge, to the edge to calculate the slope. And then finally, how you want to see the length or the slope displayed, either feet per foot or in percent. I generally go with percent myself. Um, there's a couple things like that. Now, let's go back to the general tab and get ready to set up our design. So we're going to do a storm sewer network, and the active file, network file you see is not listing anything. So we're going to select a network file. In this case will be a new one, and we'll just call it storm. So it's going to make this sewer file called storm.sew. And the surface file, you can either obtain the surface by the rim elevations that you put in, or since we have a surface, we're going to select our finished grade surface. So when you set a structure down, it's going to read that surface and use that as the rim elevation. Okay. Linking the sewer network to a reference surface and center line, if it is automatic, any changes to the surface file will automatically pull up those top elevations or drop them down. So if we say, it's automatically done, then how does it update? You want to update the depth, but hold the inverts, or update the inverts holding the depth. So if it pulls the top of the structure up 5 feet, it pulls the pipe up with it. Whereas if you hold the inverts, it raises the top and it goes from a 5-foot depth to a 10-foot depth. Okay, so that's just when it redesigns as to how you want that to do. Now, I typically put that on as prompt. So if my surface were to change, it's going to tell me that it's changed. Do I want to update it? Yes or no? So that's generally a safe setting. Now, you have a series of, as Mark Long at Carlson says, libraries that you're going to be using when you pick inlets and structures and pipes and sizes and Manning's coefficients, etc. You can, it says current because over in our other settings place, we can set specific libraries, or we can go ahead and set a specific library here. and navigate over and find it. And you'll see those when we just use the current one that's set, okay? So now on the design tab, in our case, let's start in our upstream location and go downstream. And it doesn't matter, and that does not control the order that you draw your profiles in either. You can draw those profiles in either order, regardless of how you design it. You have another switch when you go to draw the profiles. Now, in the automation part, when you choose the button in the controls that says design the system, this is going to do all of these things that you tell it to do. You can automatically set all of the sizes or not. You may have specific pipe sizes that you have to use and you want to leave them alone. Otherwise, it analyzes it and sets it down to, or sets it to the size that it needs to be. You can automatically set all the invert elevations that it needs, and it will go to the minimum depth necessary in order to meet the these cover requirements and flow requirements, and make sure that your HGL is not coming up out of the ground and that sort of stuff. So all of this stuff you can have it do automatically for you if you want. And so let's go ahead and just turn these on and watch what happens when we do it. Add a step up to minimize the excavation. So yeah, we'll go ahead and do that. We'll match the pipes at the junction. We'll minimize them. And we're not going to automatically do the watershed analysis. We're going to analyze the watershed once and just let that supply the numbers. And then auto connect the structure. So if I drop a inlet up here and then come down here and drop an inlet, it's going to automatically connect a pipe or not or prompt. So then I'm going to let it prompt me for that. Various methods for your HDL computation. Typically, you would use where you are the FHWA methodology, friction slope averaging, either arithmetic or by conveyance or geometric. I'm not sure exactly the differences there. Probably it would show you in here. Design, let's see. Let's see. So see, this comes out of HEC 12 from the FHWA. Then VDOT is a simplified FHWA, whereas Ohio method is the optimal pipe size based on the smallest diameter pipe in which the discharge from selected will not exceed the just full capacity of the pipe. Okay, and then here's your friction slope averaging. Here's your arithmetic, the versus conveyance by this equation. It's a 400 radians. That's probably, huh. I'm not sure which one might be the most, maybe our conveyance method. And then our HDL offset from rim elevation. And we just sit there looking at that. Let's see. To check the HDL, if some of the HDL lines are within this value, from the rim, alerts are presented indicating potential problems. So that's if, yeah, you give it basically a limiting distance and you say, okay, if you're within this tolerance, you're okay. Otherwise, if it exceeds that, then it's going to give you a warning. So if you leave it at 0, it'll tell you if you come out of the ground. Minimum time of concentrations, etc., which we typically would have as a 5 or a 6 minute minimum. Your local jurisdiction usually sets that value. And a maximum gutter spread, let's put like a 3-foot gutter spread, uh, which it will allow to pond at a gutter. Otherwise, it will give you a warning that you've exceeded it. And the initial network structure name, instead of MH1, let's call that IN1 for inlet 1. And then it'll just count those up. And that's just a default starting label. And the tributary pipe connect action is to, if you change a pipe, a slope or an invert, then it's going to either lower all downstream mainline pipes or lower by the current or the minimum slope, or raise all incoming pipes by the current slope or the current or minimum, and then raise any tributary pipes at the downstream side only. And so typically we're going up to down, we're going to lower any downstream pipes by the current slope. So if we drop a pipe in the upstream reaches, it's going to then push the rest of the system down. Let's see, get the rim elevation, inlet location. That's typically, it's going to read the surface there where we put the inlet down. And you can always capture all of the inlet flow. Otherwise, it will take this gutter spread and it will bypass inlets and keep going down the system to the next one. And that's our bypass that's enabled if it's unchecked. And you can have you can disregard the pipe travel time if there's no runoff at the downstream end. You can allow the invert in to be less than the invert out at structures. Now, generally in a purely gravity situation, that would never happen. You're always going to have your invert outs lower than your invert ins. However, here in Pittsburgh, for instance, we have certain structures sometimes that the inverts come in, but they have to surcharge the structure before they'll start to drain. It sort of builds in some in-system storage capacity. They do that because of the flooding issues. So you can do that if you'd like. And this is whether you calculate your headwater depth using the HY8 culvert methodology from the HEC 2 or 12, I forget which HEC document defines the HY8 systems. But we'll just leave that, take the default. Now let's go to the drainage tab for a minute and look at these methods. We're going to stick with our rational method here in our small system. And we use the peak discharge computation. We'll adjust the coefficients for higher frequency storm. No. Use a different rain event for the gutter spread and ponding depth. No. Now, the rainfall. And here's our return periods and durations. But here's where we can use this rainfall library. And you've got libraries that you create, or you can download some NOAA data. You can import from another rainfall file, etc. Or if we say a new library that we're going to use. So let's use, do you know which particular one that you typically use on your designs?
Um, Usually the NOAA Atlas 14
Okay. And then we're going to be, let's pretend we're up where you are.
Northeast.
Yeah, so we would be in there northeast. And we pick, oh dear, I didn't mean to pick that. So I have no idea of where, because we're not in any kind of known system here. This is just arbitrary coordinates.
Uh,
What's about your latitude and longitude, you know?
40 something, 70 something. You could get
Let's just call it 40 and minus 70. And we'll give this an ID and we'll just call this on
42, 71, 42 negative 71.
right. So we'll just call this mass. Rainfall just for yucks. We'll say okay. And so it's bringing all the data down.
Rainfall library. No. So I typed in the 42 negative 71.
Yeah, and then just give it a name and then hit okay. All right, so there's our rainfall intensity method. And if we edit that, you can see the data that it
Mine's
just,
like downloading a geoid or something.
yep, it takes that location and reads the geoid for that and it computes, the different it's a rainfall intensity. So it's, 3.6 inches per hour on a 1 year storm for 5 minutes. So there's a 1 hour and then a 24 hour. So those would be the intensities for the various storms. And it goes up to 1,000 years, starts at 1, 2, 5, 10. You can see all that. And that's the numbers that it's going to pull from when it goes to figure out the rainfall for our particular rainfall events. Now there's other ones. Oh shoot, let me go back to that. We're going to use this one. But there's other ways that you can calculate these. Now we're going to use a mass rainfall and we'll use, say, what do you typically have to convey for your storm systems? 25s or,
25.
yeah.
Mine's still loading the geoids, by the way.
Oh, okay, that's fine.
So it's doing it all. Hmm. How long is it supposed to take?
It should be coming close because it's still like, are the geoid numbers still changing?
It just keeps popping up. NE
Yeah.
500 year oh 03, 200 year oh 03, 100 year oh 03, etc.
Yeah, it should wrap up here in a few seconds, a minute or so maybe. Do you get the lines above where it says download of such and such completed successfully?
Yep.
See, you
Yeah,
see,
it's going through all those. And there's a little pop-up box every time it downloads a new one.
yeah.
It's on the 12-hour. Oh, now we're on the 24-hour. And we're done.
You say it's done now?
Yeah.
Okay, doke. So
Okay.
that'll be what we use for that. Now that said, that we've identified the library to use. We look at our pipes manhole tabs, we'll set our covers, let's say a minimum cover of 3 feet, maximum 10. Minimum velocities, and you generally those are dictated to you. Minimum slope, let's say 0.5% maybe. We'll go every 300 feet between structures. No drop across. Let's see, like here in Pittsburgh, we have to use I think we do a 1/10 of a foot drop across a structure. Just to make sure they get drained.
Yeah.
So you can set that, let's put that in at 0.1.
I don't think I've run into a specific requirement for that, but that's typically what we put.
Okay. And then when we say to match the pipes at the junction, what do we want to match, inverts or crowns? Well, there's reasons to do one or the other. And typically, if we match inverts, of course, that's going to, control you may wind up with a hydraulic jump coming out of the structure. But the biggest thing that you want to, when you design a sanitary system, you typically want to match the crowns as opposed to the inverts because of the hydrogen sulfide gas generation. I It has something to do with that, and I'm trying to recall the actual mechanism that it's doing there. Um, so typically, if you go from a 12-inch pipe to an 18-inch pipe, is it going to be, is it going to drop 6 inches coming out of the structure if you match the crowns versus if you match the inverts, it just makes a bigger pipe taller, It's pretty self-explanatory, and there's a reason why you would do one versus the other. I don't think the help system identifies that necessarily. It's under pipe settings, match. Oh, there, I tell you, six slope. Yeah, that's all it says, is that it's going to match that. So, um, but
So like it's sanitary sewer matched to crowns and storm matched to inverts.
yeah, that's generally the rule of thumb. Um, and then here you're going to put a design criteria, and this design criteria means when the computer is going to do the automatic design, is it going to base that design on whether you want to maintain the slope necessary to convey the runoff, or if you have to adjust the slope to meet cover conditions, then it will do, or slopes and depths and inverts, it will do those to try to meet those minimum maximum covers, um, or otherwise slope conditions to make sure that your slope is within these values here, or covers. So that's just you know basically a first approximation as to what you want to use. And you're going to check for minimum cover either at the structures or all along the pipes, so that you don't, let's say you're running a pipe from an inlet that's upstream of a sag in the road, and you connect to an inlet that's downstream on the up, as the road rises back up. It can check for minimum cover. You might have minimum cover at the structures, but you might daylight the pipe out of the ground, or come too close to the ground as it goes under the low spot if you only check at structures.
Yeah.
And that may be okay because you might be going through open field or whatever. And if you get a pipe coming out of the ground, you just go and throw some dirt on top of it. It's designed, some grading to take care of that. And again, it's just for checking at and automated design depth, that sort of stuff. And we're going to size our pipe at the target flow depth, and we're going to put this in at an 80% flow, which is our most efficient flow. And we're not going to have easement zones in play here at all. We won't do anything on the laterals. Won't matter what was said here. Error checks. We're not going to check for collisions during design, but we'll use the manual checking. And then that should be all that we need. And we'll say, okay, so we've set up our settings that are going to be in play. Now,
Guys save as like,
you can, and then that's something that you can load back later. So you can have multiple different settings files. And when you save as, you're saving the settings file so that you could load it later without having to put those values back in. But they stick, like it will stay whatever you set that to be for the next time, even with another file that you load up, another drawing file, it will still keep those values until you change them. But if you have, you know, differing jurisdictions that might have different requirements, you can set those up and load and save as you need. Okay. Now, if we look at our libraries and we look at our rational rainfall library, there's the one that we just did. There's a rainfall intensity lookup table to Hydro 35 or TP40 methodology. If I look at that, you can see these different values. I can actually go and pick something from the map. Let's go up here to Massachusetts a ways. Let's say right in there, Boston area there. We'll get a 24-hour, 25-year. Let's find Mass. Did it set Massachusetts? No.
how did you get to that?
I went to this TP40 based
Yeah.
and I came down here and hit the map.
Oh, okay. Um, 24-hour duration, 25-year storm.
I put like a 350-foot elevation. It's about an average elevation of my site here, and I hit my map. I went to say a 25-year, 24-hour duration. There's Massachusetts. And if I pick right in here, for instance, see it's when you zoom out of that, when you saw that map, it's got those and then that gives me a 5.44 inch rainfall. But if I look at that again, for instance, you see those contour lines, those are inches. So it's interpolating between those rainfall depths. Now, I may have to go back and find it again. Massachusetts, we'll pick 25, 24. You see those numbers are changing. So pick up here in the northeast part, and it reads me as a 5.43. And then when we hit computation, it's going to actually fill out this rainfall intensity in these. And look at this, say 25-year. Let's look at, say, a 15-minute time of concentration. That gives me a 5.907 inches per hour as an intensity. And so it uses this table to interpolate these values and bring back those numbers for us. So now here's our 2-year and 100-year, and those are just basically summations. And you may have values given to you for what these are, and it will use those as seed values to do that computation and look those up. Okay. Not their TP40 method. You got a Hydro 35 method. You've also got the same type of map, but that's just the eastern part of the US. Again, Massachusetts, and we're going to get a 100-year, 1 hour. Pick in there, we get a 2.5 inch rainfall. So then it will calculate, and again, come up with that same type of IDF lookup, and populates all these values based on those seed values, and maybe a 5-minute, and it calculates an intensity for that particular storm. Okay, so very,
5 minutes for the
say again.
5 minutes for this one, but 15 minutes for the other one.
Oh, yeah, I just put in a value that, that just one that I might have been interested in. It didn't, I'm just showing you how it does the calculation. It uses that to calculate that intensity. But what we did when we made this mass rainfall, we downloaded this data. So this is actual data from the National Oceanographic and Atmospheric Administration. And so now it's using that. And if I edit this, for instance, you see you can reset a return period. You can make all these little edits to this. You can do, computations. You come up with these same numbers. And let's look at say a 12-minute, and it'll calculate that intensity for that particular time of concentration at any given year that you want. So it's just showing you how all of these things can be calculated from these tables. It's basically just interpolating the table as
Okay.
as it goes. Okay. So that's going to be the one that we use when we calculate the number. So we got, what was there, 5 point something. And now if we look back at our, let's see here, I never went off tracking, but let me take a peek real quick at our watershed analysis. I think, no, it doesn't. Some of these, it will take those numbers and feed into the next calculations. This analysis one doesn't do that. All right, so we've set that up. We'll take a look at another couple of libraries here. If you got an inlet library, you've got combination, which is a curb opening as well as a grate opening, on grade, curb only, grate only, and you can double click and edit those, and you set your grate dimensions, your curb, if it's on sag curb, and if it's a slotted top, uh, you know, different things you can calculate, the flow to inlet if you know a particular incoming flow, longitudinal slope versus the cross slope of the pavement, which is like 0.02 feet per foot, like a 2%. And if you're on a road that's at a 5% grade, would be a, 0.05 feet per foot. Mannings, we'll look that up as a concrete gutter, asphalt pavement. We'll say 0.013. It's on grade. Calculate these numbers. Oops, need some flow. Let's say it's a 3.5 CFS. Calculate that. So it's going to intercept 2 CFS. It's going to bypass a 1.5. That would give me a 7.9, almost an 8-foot gutter spread, and be 1.89 feet or inches of depth. So, you can get some tools here, set up any custom properties that you might want to have associated with a particular um, inlet that you are creating. When you would set your, your gutter widths and your amount of depression in the gutter, setting the slope for the gutter slope, which is, like usually it's at like a 4% instead of the road cross slope at a 2%. So this would be a 4%. A local depression like VDOT uses if you don't have one or you do have one. So all kinds of really finessing that you can do on these. But we'll use some just out of the standard library. We don't really have time to go through the nuances of creating these specific ones, but you're going to have those from your either your highway department standards, whatever you use in your designs. You're just going to put in all that information from those dimensions to create these particular type of inlets. Let's see, great on grade, I think was what we may have looked at already, combination. Great, great curb, 3-foot gutter width. Gutter depression, let's say we had a 1.5 inches. And you can set a particular symbol for those particular ones. If you choose that, you can see under inlets and manholes, you've got these different types of symbols. I think, what do we have now? An inlet 3, let's use this inlet 5. And they can be quite, you've got some of these, that are like the NC transportation down in North Carolina. They've got these, that were made up into these libraries. And those are just the symbols that it throws in the drawing. It really doesn't determine anything in terms of the calculations. So I like that one, the inlet 5. Um, you know, combination grade, that should be fine.
Um,
Okay, so that's,
Great length.
go ahead.
I just went to hit OK and it's like the great length should be greater than 0.
Oh yeah, go back to that was our inlet library. If you come in here, this the great length, and here's different types of these types of grates. This great length right here should be, it's how long this grate is. So I've got a 3-foot grate and a 2-foot width
Okay,
on mine. Okay.
mine was defaulted to 0.
All right. So then let's see, look at the pipe library, or let's look at sewer structures first. And you've got, box inlets, you got round manholes, and you got outfalls. Okay, and we'll take a look at a couple of these. Like here's a 6x4, and you can see that it's got a length of 6, a width of 4, a fixed height, but there's not a fixed height, and a certain wall thickness. And the reason it has those is these connections at the structure walls, you can actually put these in to be, instead of going from the actual center to the center of the, from the center of the structure to the center of the next structure, that might put a pipe coming out through a corner. So you can offset these to make sure that they come out of a particular face and don't hit the corner. There's all kinds of really, good controls that you can do on those. The draw button, we'll go over here and draw it in the, like a little detail. And then you've got, your manholes. and how they show up in 3D. If you taper, let's see, there's a 4 foot and a taper height, let's say is a 1 foot taper. And let's go to a 1/2 foot bottom diameter, 4 foot. Let's see, a top diameter of 2 feet. There we go. And a taper height of like 2 feet. Let's say 1 foot still. Let's do a 1 foot. There we go. So there's an even symmetric taper. There's an upstream taper and a downstream taper, and you can see what it would look like. So the structure itself goes where the main barrel is, but the inlet opening at the top, it can be, and this is if you're using these round manhole type structures. And you got this wall thickness that you can identify as well. Different boxes. And these outfalls, we'll see those, and that's where you can identify these wing wall type structures. And you give it, basically tell it the geometry, etc., the flare angles. Okay. There's another one. And the funnel would be, let's give it a width in would be, let's say a 2 feet a week. Let's make that a 4 foot. Well, so that actually makes it sort of a flared in piece kind of type symbol. For outfalls, like when you discharge into a side of a pond or something. Okay. And we'll use one of those. We'll have one of those in there. You can see how you can set it into the ground and do all that stuff as you were going along with it. All right. So again, all of these things are very customizable and very fine tunable. And if you look at the help system, let me see if it shows you about, yeah, here's what I was talking about, these custom offsets. So if you've got a pipe coming from center to center, it might be coming through the corner of the boxes, but you don't want that to be. You want it to skew it over enough to hit the wall and stay off the corner. And that's where you would do that in that edit. All right,
If
so
I had square structures.
say again.
If I had square or rectangular structures.
Yes, for these, yeah. The round structures won't matter where they come out of. See, can you see this real light blue lines here? There's an inlet showing with pipe connections.
Yeah. Well, not on your screen, but I can on mine.
Yeah, okay. So that's showing you what it would look like in the system design. And there's that offset. So that pulled the pipe into the face instead of going to center. It skews it over so you don't hit those corners. And that gives you put them in as factors relative to the length, either the width or the length of the structure wall itself. Okay. So, or just skewed relative orientation of the pipes. Yeah. So, but for what we're going to have time to do today, we're just going to go center to center and let them ride. But look at those when you get a chance to figure those things out. Okay. So now let's do a couple of little other computations here that we're going to typically use. Frequency amount. Okay, let's see. Here's our sub watersheds by land use. Let's look at this a minute. We go back to watershed and choose watershed analysis and load up our surface. Now let's draw our watersheds. I'm going to uncheck this fill. I'm just going to draw the watershed. And I'm not going to draw the sinks or ponds, just the watershed boundaries. I'll put in that 5-inch rainfall and then choose draw. As soon as it gets through thinking.
I was gonna zoom in and it populated.
Come on. There we go. All right. So we now have our watershed boundaries drawn, and let's see if we choose this one or this one. Let's say this one. Notice we have some various land cover and different things in there. Now, remember when we did the definition where we put these various things in there? Let's look at this watershed. Let me see what layer that's on. Watershed perim. Or watershed line work is on watershed perim. And if we labeled those, we could put those on watershed text, etc. But we'll just use that perimeter. And then if we go to our subwatersheds by land use, we're going to select the particular watershed. So I'm going to get this one here, which would be this one there, and select land use closed polylines. Well, I'm just going to select them all. Wow, did that? Well, you can see what it did. This didn't used to fracture like that. It basically selects those and you see how it trims them off at the watershed boundary is what it's doing. That's not how that was supposed to go. Let me clear that a minute. Great. Oh, crap. I just did the wrong thing. Let's undo. All right, I'm at to undo till I get back to there. I think what I did is it took, see, I was supposed to have ignored those. So now if I go back to land area and if I pick that watershed, now select the closed polylines. It's going to probably complain that they're not closed. Let me see if that, yeah, see what it does is it just basically chops out the, see how it chopped the road and stopped and came along there. And now I've got this one as a separate one.
Yeah.
So that actually fractures the drawing. So I'm going to undo that. I don't really want to have that broken. I wanted to get it to report. So now let's make sure none of those are, that's still fractured. There we go. There's no, I think all that's going to do is to break that. I don't know why you would ever want to do that. Oh, well. So if we, let's look at our calculate C factors. And you can do, say choose if we select a sub area, let's select the one that has their roadway in it. Let's see here. Select a watershed is what I need to do. Let's see, by perimeter. There we go. That's what I was wanting after. So to show
Find the sub
you
area.
now, so we've got this under watershed. We're going to calculate this combined C factor. And we will, I'm going to put it in acres here, for instance, and we can select these different areas, pick it by an interior point, but we have our watershed boundary. So I'm going to select that watershed, which was that one.
Not the exterior one.
I mean, you can, yeah, but well, these are watershed boundaries. It's not that entire overall. Um,
Oh, okay.
and so if I choose, let's see, choose by perimeter and choose that within that particular watershed, I've got roofs, 20% or 19.75% are roofs, 19.9 are streets, and the rest of it, 60 is my lawns. Now, and if you did do that as the overall,
Mine just brought up grass.
if it brought up grass, look at your watershed, define watershed layers. Is that one that it's finding? See if you have this one right here, regions
Yeah,
defined.
that's defined.
Okay.
So
And you do your watershed boundaries, right?
they're all over the place. Yeah, they
So
look like yours.
if you say watershed,
It's a regions. There
calculate
should
the,
be a regions layer and then a watershed layer. Those are both. Oh, nice.
well, let me see here. This is on layer watershed perim. So under my define watershed layers, I've got this regions, what do you have defined here? Just like mine?
Yeah,
Okay.
my colors are, I think I have like 104 instead of 80, but yeah.
Oh, I don't care about the colors. Yeah. Down here it says watershed line work layer. Hit the set button and set that to watershed perim.
Oh, it's a watershed.
And then choose OK. And let's see what
Watershed
that,
brim. Okay.
I'm not sure that's going to fix what we're looking after, but we'll go back to watershed and calculate our C factor. I'll clear mine. And I'm going to pick this button that says select the watershed. And when I do that, I'm going to come down here at the command line where it says, do you want to select by a perimeter or by interior? I'm going to choose perimeter. And then I'm going to select the closed polyline of the watershed that I'm after, which will be, see there, it gives me two choices here because they're, you know, adjoining or abutting each other. So I'm looking for this one right here in the middle that includes my roads. And that's where it goes through and pulls out these. Now you say you're still getting grass?
Nope, that's fixed now.
Oh, okay, good.
So that has to be watershed brim. Okay.
Uh, I don't, I don't think so. I don't think that matters. So if I just put this back like this, let me see, it might. I'll put that back like you had yours. I'll calculate, I'll clear, I'll pick the watershed, which by perimeter, I'll pick here. Yeah, see that part doesn't really matter.
Okay. Cool.
I don't have grass. I don't know, maybe you missed picked or something. I don't know. I don't know why it would have said grass, but it was reading that grass by the fact that something within that watershed in your drawing was not covered by one of those other. Yeah, but you use region and that should have gotten everything else. I'm not sure. That's, oh, shoot, I undid the wrong. This was the one I was supposed to get rid of. Make sure I've got that gone now. Okay, now that's gone. Now if I calculate my C factor, clear this, pick the watershed. See, it still should just take the picked line. Let's see, by perimeter. I pick that. Yeah, see, it's not really reading that layer name.
Maybe something else.
Yeah, it could have been that you just maybe mispicked somehow or another. Why? But if
Hmm.
if grass comes up, it's pulling that from this because this says that's my default. So there's something within yours that might not be defined. But that's okay. That's neither here nor there. So and then same thing with their time of concentration. If we use say a rational method, uh, you can select a coefficient from a table. If you have this as just an overall, or in that case, you see this runoff coefficient of 0.45. Let me see if I calculate the C factor. See this down here, the calculated C factor of 0.452?
Calculate C factor. Mine says 0.83.
What do you have these same areas, for instance, up here?
So yeah, you picked like the big one that kind of,
I picked the one that sort of the roadway is in.
yeah, that's what I picked.
And what do you have for your areas here? I'm in acres.
Uh, 7.5 streets, 81 roofs, 1.85 lawns. So that's something's off there.
All right, so go back to select your watershed. Again, hit that button again.
clear, select watershed.
Choose by parameter, select watershed, and get the one. And that was that one. In my case, I came up with these numbers.
Now it's got different numbers.
Now you should have a calculated C factor that's somewhere between, see, I've got a 0.85, a 0.82, and a 0.2. So this is my calculated C factor of 0.452 over 7.56 acres.
There's a rose line in there. Where did that come?
All right, do this. I'm going to spend a whole lot more time when we get to these.
Yeah,
But if we define our watershed layer, I'm sorry, if I go back to watershed and look at my watershed analysis,
there's like
what size rainfall did you have?
I had 5.
All right, so that should have worked. Do your watershed boundaries look like mine?
Yeah.
Roughly?
Do
Okay,
you have is when I select, like if I just like grab um like right there.
yeah. See, that's the one that I'm using, but you see, it neighbors.
So it was picking.
Do you when you go to select it, do you get that little box up that lets you pick which one you're picking?
No, but it was select because I could see it highlighting the other side.
Okay.
I'm pretty sure. So I don't know if this has any. So when I select that watershed, like if I just like windowed it, there's the two watershed 25. If I just grab like the watershed line in one spot, there's 7 polylines and 18 3D polylines.
Um,
It's created like there's the watershed thick bounded polyline, and then there's pad lines through the whole thing.
yes, I mean, well, it should still be the watershed itself. Do you, um, there's a thing called called selection
Like
cycle. Do you have selection cycling on? If you type selection C and then so selection cycling should come up. When that comes up, what is yours set to?
0.
Make that a 2.
One,
And
0
now
or 1.
it doesn't let you do a 2?
Selection, cycling. Okay, maybe I picked something else. Oh, what else did I just change? Okay, yeah, it took me to selection and display the first time by accident. Okay,
Oh,
all
okay.
right.
So selection cycling 2. Now, if you hover the mouse over one of those lines, do you see a little icon that pops up, looks like two stacked pieces of paper?
Yeah,
All right, so selection cycling's on. So now if you were going to, let's just right click and choose, it's not right. Let's just type the word copy. We're not going to do the command, but just choose copy. And then when you hover over one of those lines and you click, it should bring this up, right?
uh, I have this like a dozen 3D polylines all on the pad layer. How did that even happen?
Right, hang on a minute.
There was like and I deleted one. There was like a road line, and there's also a pad line that's that follows my watershed line layer.
Oh,
Look at it.
that's probably left over from back when we did that fractured business.
Oh,
So like you're saying, like this pad line doesn't do this, it walks around here.
that's correct. And
Okay.
there's also another line. There's like six. There's like 10 of them, and they follow the whole watershed, also on the pad line.
Yeah. Uh
That's from fracturing.
yeah, so let's see. Did you have you saved your drawing since you did that command?
Uh, Probably.
What okay. Do you have the original drawing anywhere?
Yeah, I can go back to. I have it saved,
Yeah,
like
go back
the
to that,
original.
close this drawing and go back and bring that one in and reload that drawing. Now, all these other things are still going to stay. So that part's good. Um, so when you reload the drawing,
I'm back to like the original one that you sent me.
okay, so now go to watershed and choose watershed analysis. Choose your FG, put in,
Watching
put in
analysis.
5-inch rainfall and draw your watershed perimeters.
Watershed perimeters, 5-inch rainfall, raw.
And you should get something like this.
The fracturing bit. What I'm blanking on how that happened.
That was this watershed, sub-watershed by land use. That's what it took all of those land use layers, those polylines on the on the land use layers, and it fractured them along the watershed boundaries.
Oh, okay.
But when I did mine and noticed all those little blue lines and stuff, it actually fractured all my contour lines along those as well. Because
Oh, so you undid it and then.
yeah, I did an undo all the way back. So,
Oh, okay. I
all right.
missed that. Sorry.
But you now have your boundaries drawn.
Yep. Yeah, I got my boundaries back.
Right. So exit that, and now you could go to that calculate a C factor and
Select
choose
watershed.
select watershed and choose by perimeter at the command line and then pick, and it should come up with something like that.
Okay, I got 0.444, so I'm only a couple
That,
thousandths off what you got.
that should be all right. Maybe a
Oh,
slight difference in the surface file that you created versus mine,
right, that's true.
but you basically got a 0.44-ish, 5-ish as that C factor. Now, while we're in there, and let's just look at that one particular um, watershed. We'll ignore these others for the moment. And let's go to the watershed menu and let's do this. I want to do a runoff tracking, this
Yeah.
command that's, so I'm going to choose my surface. I'm going to pick individually. I'll keep my 5-inch rainfall up here. And I'll use a 3D polyline. I would say, okay, I'm going to come up here after it reads the surface. It's going to prompt me to pick a point. And I'm going to come up here and say, come up here to this high point in the road up here. I'm just going to click a spot there and then hit enter to end it. And it should generate something like that. Okay. So that would be right now with no inlets to intercept that flow. That is my longest flow route within that sub watershed. Possibly, you know, if I'd
Yep.
if I'd have picked the other side and it wrapped around this way, that might have proved to be a little longer. In fact, I think I'll do that just to see. And I'll now pick on this side. And now it goes down, basically follows the same thing. The only difference is this one jumps the center line and joins it. So that one has a length of 1243.26, whereas this one has a length of 1264. So that one is actually technically longer, but we'll just leave this one here for now that we drew. And we'll go back to now watershed, and we're going to choose this time of concentration by the rational method. And right now you see that coefficient that we calculated should be in your table already.
Oh, okay. Yep.
Okay, and then the length of flow and the slope of the flow path, if you know what those numbers are, you could calculate those or put those in manually, or you can select the flow line from the screen. So I'm going to now pick that flow path, and it read all that information there. And then I hit the calculate button, and it gives me, 24.7 minutes. When it rains up here, it takes just under half an hour to get down to that pond. Okay.
Oh, report.
Well, if you do a report, it just basically gives you this, and that can be part of your submittals, and you can choose, um, you know, present or developed, pre-construction, post-construction kind of, you can give it titles for project and all that kind of stuff. It just basically creates little files that you can use to make as part of your submittal. Okay, so now we've got, and keep in mind, by the way, you're used to doing this in HydroCAD, and HydroCAD's still going to generate the most accepted report formats and such, and you still would do all that, but you would typically, put these you would use this to generate the drawing stuff and then kick that over to HydroCAD and let it do the heavy lifting for that. Now,
Yep.
so one thing, let's take a look at something here while we've got it. Let's isolate the um, watershed boundary layer. And I'm going to do that with my view isolate layers. And I'm just going to pick one of those, doesn't matter which one, so that I've got this. Okay. Now let's create a new layer called watershed underscore text, and we'll set that current. Cannot be made current. Why? Oh, it's frozen. Okay, so anyway, we'll leave it there. We've created it.
Whoa, what the?
Let me turn these back on. So now I've got this watershed text, and I'm going to make that my current. And then I'm going to isolate my watershed boundaries. So now you can see I've got this watershed perimeter. That's the one that I isolated. So it's thawed, and watershed text, apparently when I isolated it, didn't keep it. So I'm going to thaw that one as well and then set it current. So what I want to do is I'm going to put some labels in here just to show you how this is going to work in our Explorer. So I'm going to check my text style here a minute, just my standard. I'm going to use something a little nicer. And I'm going to just put some text down here. And I'm going to put a point, say, up here, and I'll make it, say, that tall, east. And the text I want to put in there is WS1. And I'm going to put WS2, WS3. Let's see, I've got 1, 2. Let's just put 9 in there. And I'm going to move some of these things around. Just for some illustrative purposes here. So I'm basically identifying these various subcatchments. And see, that's also 1, that's 4, so we got a 7 over here. That's, we got an 8 down here. And we'll do like that. That should be enough to identify. Now, make sure that that's on a layer called watershed text or something that's on a layer by itself, okay?
Yeah.
Now let's go back and we'll go to view and we'll just say thaw/on all layers. And let's go back to our watershed, define watershed layers, and make sure that we have chosen that layer where those labels are, and the line work layer should be on watershed parim. So we got parim and text as those layers. And our runoff flow line layer is going to be on, we had that one flow off or flow line layer, which I think was on this layer called runoff. I'll double check it. It's this line right here. Yes, it's on layer runoff. So in I defined our layers, I've got my runoff flow line layers on runoff, my watershed parim, my watershed text. Okay. So so I've got my runoff for that watershed 1. Let's look for watershed 3, for instance. That would, wait a minute, where is 3? Is this?
Oh, 1 and 3 are probably the same.
Yeah, so 3 wasn't correct. Let's just stick him over there. So I've got 2, I've got 1. If I had, oh, I know what, let's put 3 over, no, that's still part of 1. Yeah, if I had left my hatching turned on, I could see these a little better. I think we're okay now. All right, so we've got some things that can identify. And if we look at now, we've got a rainfall, we've got our time of concentration. Let's come over here to our, let's do another one of these watershed 2s. Let's do a runoff tracking. We choose our surface. We'll say, okay. If I come here, let's see, did I cross a boundary? Nope, we stayed there within watershed 2. All right, so I've got now 2 flow lines. And let's see, make sure that those will show up a little bigger for you on the screen. There you go. So we got our flow lines, we got labels, we've got boundaries. Now if we go to HydroNet, and let's look at our HydroNet Explorer. We've also got this watershed analysis type tool, which you can, it's basically, it's exactly that same tool, that watershed analysis. I'll go ahead and exit. That's available on this HydroNet menu. It's the same command as this one. Define layers is the same as define layers. I don't know why they do that, but our HydroNet Explorer will make a new file, and Hydro example is fine. It defaults to the drawing file name. We say open. And now here's where you can either, pick all these things and add these individually, or you can have this set and you got rainfall events. Like right now, we don't have an event, but you can go to settings. And here we're going to use this runoff method. We use the rational method, storage indication for pond routing, reach routing, storage indicator, 24-hour, 0.1 hours, use plan view location for schematic look at it, doesn't matter for that. We set our surface file to use FG, report our slopes as percents, subcatchments. That's just if we're going to, let's see, if we call it WS1, that should fit. We'll go to acres, curve, time of concentration. We use TR55 for this. Process the curve number, runoff coefficients. Use the 3D flow line slope as the land slope in the time of concentration calculation. Yep, we'll do that. Pond, that's fine, I don't care. Reach, we won't do ponds necessarily. We go to rainfall, and let's choose our rainfall library and choose our mass rainfall now from the library. And we'll choose the modified rational hydrographs, and that's all good for those. Storm duration for, oops, yeah, 24-hour for a 25-year event. And that's just for our reporting. All right, I think that should do for us, and we'll say okay. So now we've loaded our data. Let's come over here now and choose our 25-year storm. Let's see this button. That's a HydroNet file. So we choose our 25-year rainfall event, and then down here below, we can add these individual things. But remember those layer names where we defined the watersheds? So if you choose this update button, this little up arrow,
Yeah.
I want to update sub areas, plan location, create new subcatchments. No, I won't. And then export to HydroCAD after you update if you wanted. But I'll say, okay, now it's going to read the surface. So as it's doing that, it should now come in here and find the subcatchments, these little watersheds that we made. And populate this list for us.
We didn't label all of them, just the main ones.
Yeah, just a few. In fact, if it doesn't find those other ones, it won't find them.
Okay.
So Yeah, it's still working over here. Call HydroNet 2140. So this HydroNet processing is actually what Carlson uses internally. So as this comes up, man, this is usually a lot. I don't understand what's holding this up. Let me create these subcatchments.
No watershed layers found.
Ah, there we go. So if I say okay to that, there we go.
Okay.
So
So
you do have to say update. And here I got a warning that said, see, I had the label in the same location. So 3 and 6 were the same. So I'm going to take 6 out. Want to remove watershed 6. Yep. And then I can take this particular piece of text out as well. And
mine did not do that.
all right. So if we exit this, no, I'm not going to say the changes. So now apparently, yeah, I had 2 labels here. So I took out that 6. So now if we go back to our HydroNet Explorer and let's just start over again. We'll go to new HydroNet example, say open. Nothing's in over here. I go to my settings. I put this information in. I have to choose my surface file. So I'm going to hit set and choose my FG. I'm going to use my runoff method as rational. I will use a 24-hour end time. All of that's good. Subcatchments, WS1, tier 55 for time of concentration. These are checked on. Ponds I'm not doing, links and rainfall. Let's use my rain library for my mass rainfall.
What the heck? Rain library. It's not even showing the ones we had.
If you choose that rain library, do you not see that mass rainfall?
Nope, mine says emergency 6 hour, type 1 24 hour, and type 3 24 hour with a few in between. What the heck? Change this.
I tell you what, remember we did all that downloading stuff? That's where we created this mass rainfall.
Yeah,
All right, just choose one. It doesn't really matter. We're gonna run out of daylight if we're, you
okay, yeah,
know, just choose one. It doesn't matter. So
all right.
we'll choose our modified rational.
Does it, because remember I kind of reload, I started a new drawing.
That, no, that wouldn't affect it.
Okay,
It should still be there, but, because it stores in a separate file. So I'm going to choose this storm duration of 24 hours, come down here, choose my 25 year and say, okay. So now I'm going to pull this down and choose 25 year. Now nothing is added up here yet, but if I hit this update button, I'm going to update any sub areas, any plan locations, now I had to turn on, and this is what I missed the first time. I said create new subcatchments. That's where it reads the layers, reads the boundaries, and reads the text. And then, of course, you could export to HydroCAD, but we're going to just say update that. It's going to come through here, read everything. And there it is, created 8 new subcatchments. And I've got 1, 2, 3, 4, 5, 7, 8, 9, because remember I took the 6 out. So
yeah,
it read the text and everything's fine. Over here's number 5. Here's number 2. Here's number 1. That's our big one that we've been working with. And so let's take a look now at say number 1. And if we right click and choose edit that, you can see there's our name.
Error, mine's error, the watershed layers are defined in rational method.
What does it say?
I went to update, create new subcatchments, update subcatchments. I checked that box. Error, the watershed layers are defined in rational method.
Watershed layers are defined
Yes.
in rational method.
Yep.
All right, go back to your settings button.
Bingo.
Uh,
Overlap, updated 8 subcatchments.
okay.
And where'd they go? They're not showing up in the HydroNet though.
All right, hit your update button again.
Updated 8 subcatchments. Okay.
And say, okay.
That's all that.
All that, and it should say what updated.
Rainfall, modifying. Okay, because I didn't have rational selected, it
Uh-huh.
switched back to the TR20. I pick rational. I go to rainfall. Now I can pick the mass rainfall. 25 year, 24. Okay.
There, there you go.
25 year.
And then come out here and choose their 25 years as well.
Yep. Updated 8 subcatchments.
And you get a list now?
I still do not have a list.
All right. I'm going to save this and exit, and I'm going to stop my share, and I'm going to have you share the screen. Do you know how to do all that with Zoom?
Yeah.
All right,
So,
go ahead and share your screen. Let me take a look.
can you see me?
No, hold on. Yes. All right.
Yep.
Let me request remote control.
Proof.
All right, so I requested remote control. And that's it. Beep, 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 beep. And I've got this guy on watershed text. This guy's on watershed, just watershed, not watershed parim.
It is set. So, um,
So let's go back
in,
to watershed, define layers. And yours is set correctly there. It's mine say parim, yours is just watershed, but that's what it is.
yeah, I had previously gone through those settings like
Yeah.
in advance of this class. I probably shouldn't have changed them, or actually, no, it was before I even signed up for this class. I tried playing around with it a little bit, and
Yeah.
I
No,
like,
no, no. Yeah, that's absolutely fine that you did. So now let me take a look at what might be different. Rational method, storage indication, uh, reach routing, none of that's going to matter there. But rational method, 24, let's see, set my surface file. Did you do that?
oh, that could be it.
Where's our,
Hydro PR proposed.
oh, PR, there we go.
Yeah,
Okay. Not in the current project path.
he didn't say that. It,
It's
yeah,
okay. Um, so now rational subcatchments. It doesn't matter whichever one you want. We'll look at that here. Let's use curve. All right, our rainfall now we got our mass rainfall. Our 24 duration. Event name. So none of those really, this doesn't really matter. It should set this out here, but it doesn't. And we come back and we make sure we're sitting here on 25, and then we do our update. And we say, okay. Updated 8 subcatchments. And where the heck are they? See, it's used your numbers, so it's waiting for the next one to be WS10. Let me save that, exit, and come back. While we're here, what version of AutoCAD are you using?
2024.
Okay, same. Let's see here. Explorer.
And when I said I played around with this stuff, all I did was try to make the layers like to our, because we have like our own like watershed line PR or
Right.
watershed text PR, watershed text
None of that
existing.
should matter.
And then I started to set them back to the what you had to try and stay consistent.
Yeah, I mean, but none of that stuff really should have mattered. Let's see here. Percent subcatchments, WS1, acres, territory 5. Fall. Storm duration 24. Okay. And now 25-year.
Oh,
I do not know why. There should have been no particular reason.
so just
Everything I could see before, I just started a new one. All right. So I'm going to stop remote and I will stop your share and I'll go back to my share.
so you just made a
Yeah, I
new
just made you
internet file.
a new file, right?
Okay.
All right, so
Back in business.
there we are. And so now if I look at each one, I'm going to right click now and choose edit. And you can choose flows. So that gives me my acres. My runoff coefficient, there's that 0.45 that I had before. That's the edits that I did. But if you look at now watershed 2 and edit that, you see it's got a different number and it's found different values.
It's
It's
automatically building it from the bounded polylines.
exactly right. So now watershed 3, what else did we have? There's a nice one there. If we edit that, see, well, it's still 4.2. But all of these numbers are becoming different. Now, if there's, and you see this time of concentration for this one, we didn't have a flow line, okay? But if we look at 1 and 2, we've got a time of concentration. We've got this length and slope at red. We selected it from the screen. If we calculate now and say, okay, now it's going to fill this in for that time of concentration. I'll say, okay.
Edit PC, edit, select flow from, so it's not, it didn't automatically grab the
It
runoff.
didn't grab that because had we calculated it before based on the watershed menus over here, these commands, it would have populated those. But since we're using HydroNet to do all this stuff, it found the flow line, but we didn't get, see, it's showing us here with the length and slope. So if I edit that TC and now just hit the calculate button, it's going to calculate that. So that's 13.2 minutes for that one. See, I've got 13.2 with that particular 8.4 slope at a 483 foot length.
So we have the option to either calculate or select flow line from screen.
Well, this one,
Yeah.
it should have already selected it from the screen based on it being on that layer that we defined.
Oh, okay.
Okay, that's why I only drew two of them in. See, I drew in this one and
Yeah, I have the runoff. Wow. Yeah. Okay. It didn't
and
pick
I
up.
and I also drew in that one. Now that's on a layer called runoff, and that's also defined in that watershed defined layers.
Yep.
Okay, so that's where it's reading that from, but I have to go through and check these things to make sure. And if these are blank, and if I want those to be populated, then I would fill those out. Now there's my watershed one.
Mhm.
And if you, let's see, let's do a report. Okay, so it's going to give us all these numbers. Here's my hydrograph in text, of course. But if I look at, oh, let's see, what I meant to do was go to our, save the hydrograph. I'll go to my hydrograph tab. Then there I can see the result of that hydrograph. It's pretty severe. Let's see this one. Yeah, no hydrograph there because I have no time of concentration. So, so we did get the hydrographs. The scaling on that's not real grand. So there's my peak discharge of 0.27 CFS, time to peak 0.3. So that's something weird going on with that watershed too. Let's see this one. No peak. What happened here? Let's see. There we go, 0.86 CFS. I'm not sure I buy that. Let's see here. I want to calculate my peak discharge. Let me save this. Exit that for a minute. Let's go to,
Save the changes.
yeah. So I'm going to look at my peak flow, graphical method, acres, time of concentration in minutes. Select the area from the screen. Rainfall depth, 24-hour frequency. No, this is using, it's using SCS, storm type 2. Then I choose peak flow. Oh, sorry, rational method or modified rational. Let's use rational method. There we go. Drainage area. I can select. There's my runoff coefficient. There's my drainage area. That was at time of concentration. Rainfall. I'll choose my library, my mass rainfall. I'll look at my 25-year storm. Calculate. So 3.82 inches per hour, 182 CFS, a little more like it. All right, so I can report.
I got 12 CFS.
Um,
3.78 inches per hour.
and it says, which one are you looking at? Which watershed?
Uh, I didn't pick a watershed. calculate.
Uh, over here where it says drainage area, just choose select.
Oh, the big one,
Yeah,
7 acres,
yeah.
12.
Time concentration. And then a 4. So 4 CFS for watershed 2 and 180 something for watershed 1. If
Right.
you repeat that, let's see, I'm going to pick that drainage area, select that, and make sure I get the right one.
Okay, I run 4.1 CFS for right watershed 2.
Oh, yeah, now I'm back to 12.1. What on earth is going on? I must have missed. Twenty-four, 7, 25, you calculate. Yeah, so 13. So yeah. All right. So that's giving me that. Now, does that populate this back? If I choose this existing file and update, yeah, there's that. Weighted runoff. 4.7. The peak discharge is not lining up. I don't know why. Let's see. If I put this in as 13, now 1387. And if I take that out, see, it goes back to 0.87. It's not getting, well, I don't know. Why is it not finding that?
Will those hydrographs when it exports to HydroCAD, does it just take the areas?
Yeah, because if we go to HydroCAD, uh, subcatchment time of concentration, that's an 8 DT. Okay. Yeah, see, it's giving me that same one. Well, of course, HydroCAD's doing exactly what we've given it from here. From the HydroNet Explorer is coming up with it correctly, I mean, it's taking what HydroCAD Explorer is giving it, but that's not, see, that's got a time of concentration of 13, a C factor of 0.42, 4-inch runoff depth. All of that looks actually correct. So why am I getting those different numbers? Well, I don't know. And of course, if I look at 3, it's got nothing there. We didn't have any of the time of concentrations. Uh, Peak discharge, 0.87. Okay. Peak flow. Acres, turning coefficient. Wowee. Wait a minute. No, it's still. No, see, this is still 7 runoff curve number. So that's see the storm type 1, 1A, 2, and 3. That's from SES method. That's not a rational method. Peak discharge. Maybe look. Peak discharge. Set that for a minute. Uh, I'll get it here in a minute. Wasn't that interesting? Hydrograph, rainfall, 25-year, 24-hour storm. Okay. Use rational method runoff coefficient for higher frequency storms. My peak discharge instead of hydrograph. I use my hydrograph, and then if I go to rational method, modified rational, acres, select pick the wrong one, I guess. That one, yep. There we go. Duration. 24-hour storm. Now we calculate, oops, no rainfall. Uh, Calculate that. 0.4 CFS. Oh, here we go. Let's get back to this and calculate peak discharge. Yeah, now see, that's matching. And there's our same discharge. So why, if I use, I guess, I was using a hydrograph computation, or if I use my peak discharge, rainfall durations are disabled, and the peak flow of each is calculated by the selected method, and the storm sewer network is designed to pass the peak flow, or durations are enabled and a runoff hydrograph is generated and routed. Yeah, see, that's to, if you're routing, if you're doing hydrograph routing to come up with with pond storage and all of that, we would typically do that. So adjust the rational. That's okay there, but rainfall, return period duration, or if using the rational, using hydrographs, using the rational equation. Huh. I guess it's calculating a peak discharge differently under the rational method than hydrograph routing. So why doesn't, if I'm choosing that method, why won't this? Do this? Well, I guess that's the hydrograph routing. So that, yeah. So peak flow from the hydrograph versus that rational method is this methodology, and we're gonna pop off this so we get some pipes in the ground here. Uh, when we're doing this methodology with hydrographs, it's going to route those hydrographs. So it's going to take into effect the duration of these rainfall events as well as the return period. Whereas when we're using peak discharge, it just calculates the peak discharge without considering the duration of the rainfall event. Um, it's like peak flow determination, like on a sanitary system, is just based on water usage, of course. So this, what's it doing here? It's calculating. I'm going to put this back to peak discharge method. And if I choose my peak flow rational method, that's what I want. But Let's see if it calculates peak flow using the rational method. Size area, the C factor, the time of concentration, return period, and a rainfall 5 point intensity. Yeah, okay. So that's the rational method, peak flow. Whereas if I chose graphical method, it's using the graphical method material 55. Actually, that's a type 2 is what we typically use, type 2 storms, but you're actually in the what, type 1A storms or type 3 storms?
Uh, I think we usually use type, and I'm being what I've always been told to use is type 3 here.
Yeah, it looks like that's where you see this map, and
Yeah,
that would be what you're under. We're under type 2s. But let's see, more peak
I always wondered why we did that. It's because of that map.
and the swap adjustments, the unit peak discharge. Wow. Yeah. So let's see if we use these values. It still gives me like an 11, but so yeah, so 13. So they're roughly the same. I mean, they're not the same, but that's better than 0.8. All right. Graph routing. Yeah, see, we still came up with that tiny little value. 25-year, 24-hour, 5 steps. Okay. Well, the numbers work out. It's using a different, it's the hydrograph peak flow. All right. So let's go back to watershed menu, choose our peak flow, rational method, general, and calculate. So that 13 is there. We'll exit. All right. So we've got a number to fill out where it will fill it out. All right. Let's go into our network. Let's put some pipes. And so we're going to do this by creating a sewer network, a sewer pipe network. And the first, or there's some settings that we can look at that can control how the thing labels and that sort of stuff. But if we look at the what we're gonna be using those libraries and that sort of stuff, that sort of thing. So we're going to actually create a sewer structure. So we're going to come here to this second line down in the second section called create sewer structure. And we're just going to, we can do it a number of ways. We can choose a number, use a center line curve, that sort of stuff. But we're going to locate by pick point. And I'm going to come up here at the top and notice it's reading all of this information for me. I'm going to put an inlet, say right here at, as this curve comes around. So I'm going to I'm snapped right to that little location. And there now is my IN1. You see a little marker on our field. So now what I'm going to do is I'm going to collect runoff in the street. So at that inlet, and then I'm going to put another one on the other side of the street, and I'm going to run the main down one side and, and connect across the street with little short connectors. Okay. So I've got my inlet. It puts my symbol in there. It's not rotated correctly. So we can do a number of things. Here's our system name. We can just call this our storm.
Not, does it not snap to the lines?
It did.
It did. Oh, mine doesn't.
Do you have your snapping on?
Yeah.
And did it, and it's the center point that snaps. The rotation
Pick.
we'll fix in a minute.
Okay, now okay.
All
There we
right.
go.
And
All
so
right.
now we have to tell it a couple of things here. We've got a bunch of stuff. If you look at your settings button up here, you notice it's the same thing that we looked at earlier from the pull down.
Yeah.
That's another way to get back to it or to change some things. But this is my first inlet one. I gave it a system name called Storm. And you can give it a line name and a description, etc. We can choose the inlet type. Remember those from our library?
Yeah.
Or you can even hit the little icon and go over here, and this allows you to edit and add and do things to it. But we're going to use a combination grade. And the structure that's under the inlet, you can choose a box 1, 2, 3, different manhole structures, different outfalls. So let's choose, because we're up in the upper reaches. We don't need a big one. This is a 6x4. There's a 3x4, 3x3. Let's use, say that the 3x4 as our structure. And now this reference center line, we're going to use that to help us align the symbols. So I'm going to click that little icon and choose screen pick polyline. And I'm going to just pick the center line. Now, I don't have a centerline file associated with it, but it's going to allow me to um, assign it a file, and I'm just going to call it, come on, give me the file dialog. It's going to take forever. By the way, while we're waiting on that to load the file dialog, all of this stuff that we're going through, you can, um, in these, in your training guide, in particular, it shows you some of the different labeling. And here's, for instance, you see where we're starting to put in these uh, structures,
Yeah.
how they're labeled. So that's all self-contained. You can come back through there. And it even, I think,
Dialog boxes and different which settings to.
yeah, this gives us those command structures. Here's this TR20. Yeah, I wanted to get into some of the profile drawing, but in any case, so now let's call this just Main Street. It's fine. So did not open center line, internal error. Okay, great. All right, so instead of that, we'll Let's do parallel to pipe up, parallel to pipe down. It's not changing. We'll just enter the azimuth angle. There we go. Huh. Well, all right, so, and it really has nothing to do with anything other than how it draws it. So you could actually put in a symbol, you could put in a twist screen. Enter an azimuth angle, symbol angle. You can choose this pick button and you can pick 2 points, say from here to here, except there should be 180 around that. So just make that 5 degrees. There we go. So there it's going to be sitting there. All right, so we now have our first little inlet and we need to fill out a little bit of stuff about it. We see that it reads the rim elevation, sets the rim elevation to that elevation of that picked point on the surface, which we picked on that 3D line. We're not raising it any. We've got a 4-foot depth as their starting point, which gives it an invert out of 372. We have no drop across, etc., etc. Now, the next thing we're going to do is, we've got that one structure in there now. So let's put in our the next structure. So I'm going to come up here, hit my plus, my add button here. So I'm going to add, I'll pick a point, and I'm going to come over here and just pick one opposite right in there. So it asks me now, do I want to auto connect to the closest available structure? I'll say yes. It's going to be 2272. Now remember, I'm going from uphill to downhill, so it's going to try to go down slope. And I'll now change that. Let's see, twist screen. No, I want to enter the azimuth angle and pick 2 points here to here. How about we pick and now add 180 to that to be 198. There we go. And so now it read that rim elevation is 376, whereas the previous one was whatever it was. And it is now set the pipe, which I see here now, if I go to my pipe tab, and it flows, you can see the flow arrow direction that shows me the direction it's going to go in that direction. And it's going to be a 12-inch circular pipe. And it has a 1% slope. These are just our starting values. Now you'll see when we hit our design button, it's going to update all of these different things. Okay. So we're not right now, we're just going to put in our structures and build our system. Oh, excuse me. So I'm intercepting flow here. I'm feeding it across. I'm going to come down here and put another one along this edge as my next one. And I'm doing that because that's where I want my main to go down this edge over here. So I'm going to add, I'm going to pick a point and I'll come over here and just sort of, you can see my my endpoint snap is on. So if I hold shift and right click and choose nearest, I'm going to put one right there. Now it says, do I want to auto connect to the closest structure, which was inlet 2, 107 feet? So I could say, yep. And it's going to connect me there. Parallel the pipe. Wish it would. Well, apparently, let me see. If I take that, make it a 2D. We'll pick it one more time. I don't know. It's not letting me. Not letting me create that centerline file, but if I have an alignment file, a centerline file defined for these roadways, it will let you well, it seemed to work that way. Let's see, parallel to centerline up.
There you go. Yeah, mine worked. I do the same thing.
All
Oh,
right, so apparently I had something going on.
excuse me.
All right, so that was that one. I see I've got a pipe there. Notice it's also a 12-inch circular because we haven't done any design yet. And it's also got a looking for our it's got a 7% slope because it's coming down pretty quickly. All right, now I'm going to go over to the other side of the street and I'm going to add another structure. I'm just going to come down here, not necessarily opposite. Yep. Try it again here. Let's go back to structure. There we go. Add my structure, pick a point. And I'm not going to necessarily be opposite, so we're going to be able to move these. I'll show you how this is going to work. Now, do I want to auto connect to the closest one, inlet 3? I'm going to say no at this point, just to show you how that's going to work. And that'll be parallel to center line down. There we go. And then let's see. I want to come down here and catch right in here at this flow line where it jumps. Actually, I'm going to catch it before it hits there. And then we're going to go across to their pond here. So I'm going to do another add, pick a point, go nearest, and let's just come down here and grab that guy. Yes, I will connect that one. So now there's that pipe 4 to 5. So right now I'm going 1 to 2 to 3, no connection, 4 to 5, because we're going to fix that in a minute. We're not going to use that. And I'm going to add finally our last, or not our last one, but next to last one. And I'm going to come right across from it and put one there and say, yep, I'll go ahead and connect it. And I'll switch my orientation correctly. And then, oops, up. Got to get out of there before I roll the wheel. Oh, come on. up. There we go. Now I'm going to do one more. We're going to outfall to the pond here. I'm going to pick a point, and I'm just going to come down here and say, let's outfall right in there. Auto connect, yeah, go ahead and auto connect for that. That's fine. And let's hit now back in the structure that we last made. Instead of that being inlet 7, we're going to call that outfall. And we'll have no inlet, and its structure will be this outfall wall 1. Let's see, the height of the new head wall structure is 4 feet, which is different than the current depth. So we will keep the invert update to, let's see, which is, all right, so we'll fix all of that in a minute. We'll just choose that option.
Which one did you choose?
It really didn't matter because we're going to adjust it, but I forgot which one I chose. Let's see. Well, it didn't. It
I'll
did,
put no change.
but what I'm going to want is I want the invert elevation of that pipe to be the same as this elevation, which is 354. So I want that structure to be 350. See, it's got a rim elevation of 5637. And I want the invert to be 354. Now, that might not necessarily work for us. We'll have to see. I don't know what we're starting out up here. At 378, we should be able to. All right, so now we've got a bit of a system. I'm going to hit save and exit. And we've got this in here. And I'm going to do a little housekeeping here. I'm going to freeze off my watershed layers. And in fact, I'll even I'll freeze our flow lines now. I don't really need those. I'm sort of aware of where those are. But what we want to do is take a look at what we have. We've got here's a freestanding structure. It didn't connect. I've got a couple of different things here. So we need to sort of go through and sort of sanitize this a little bit better, clean this up. So you can get back into that editor by just double clicking either the label, IN4, or the structure name or whatever. So if we say, all right, see right now IN4 connects down to IN5. So if we look on our structure tab, keep our structure tab selected, and you see these green arrows, you can go up the system, but it didn't find anything above structure 4. There's nothing that comes into structure 4. So I go down, go down, go down. I can go up, 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 but I don't have, that's as far as I can go on that particular run. And if you get a situation where you've got an inlet with multiple incoming pipes, then as you go up, it will let you choose, which branch you're going to navigate up. You can also simply choose this, let me see, you can choose this button between the plus and the minus to switch over and pick something, and it will switch you to that. Notice I'm now sitting here on inlet 3, even though it hasn't updated my graphics yet. So, so let's start up here at let's actually go down. I'm going to choose that. I'm going to come down here at the bottom. Since I'm sort of stuck here at a 354, I'm going to work my way up. And if I look at my pipe, now, when I go to that pipe, I see that I've got all of these available structures that I can use for an upstream connection, but it identifies IN6 as an upstream connection, so it knows what is there, but I can make those edits here. And let's see, what else do we want? We've got an up invert of 357.65, which if I were to look at this elevation of my center line, that's 361, 363. So our structure of should be like 360. There it is. And there's our depth. So let's go back down our downstream here. Our 356.37, but it's got an invert of 354. So 2.37 is our height. We can actually go to our outfall wall 1 and edit that and see what that's going to look like. Is that enough height? There's a 4-foot height. So 354, invert in is 354.10. Want any depth? I don't think. Let's see, 3 invert out. 354. 354.10. There we go. Rim elevation, that's what I was actually shooting for. So 360. All right, so that's just going to affect how it draws it in 3 dimensions for us. So, all right, so we've got a 354 invert out, and let's make that 354 invert on that outfall location. That's my grade elevation of that pond. And actually, I'm going to bring that up to 358 instead. So if you see what I'm doing here, I'm changing this, but now notice I'm still sitting down there at 354, but I want this to be really up here at 358, so I've got enough capacity in my pond to fill it up a little bit. So I need to move that location. So I'm going to go up here now. I'm sitting on that structure with the marker. And if I look at my northing and easting, about midway down here, but I've got a pick button. So if I choose that, now I'm going to pick a point. And notice other ways you can use point numbers. You can station an offset of the center line if you know what those are from a road design. So I'm going to pick a point. Now I'm going to go more, a little bit, less of an angle and pick right there. So notice I've now moved up to here to this higher elevation, 358. And a rim elevation, it says a 358. But if I raise it to 4 feet as a raised height, that'll take care of that wall height. We'll see what that does for us. We may be coming out of the ground a little bit with the pipe, but we'll see it. So now we've come up. We've got our pipe here, and then we notice it's got a pipe that comes in to, if I go back down, come back up, it's got an incoming pipe from inlet 4. Well, I don't really want an incoming pipe from inlet 4. I want to have nothing there. It's just going to be freestanding, nothing to connect it. So I'm going to go to my pipe, and where that pipe is connecting to that inlet, I'm going to remove it. So it's no longer there. I'm going to go back downstream. And now I'm going to choose on my pipe tab. I've got inlet 5 comes into inlet 6, but also so does inlet 3. So I choose inlet 3 and hit add, or I can simply hit the pick button and pick the structure. Okay. So it's now got 2 incoming pipes from inlet 3 and inlet 5.
Okay.
Okay. So let's go, let's see, go downstream, we'll come upstream. Now, if I want to go upstream and downstream, downstream, I go up, up. Let's see, I'm trying to go, oh, so if I switch over to this pipe and go up, see, it takes me up the other branch. Okay. So now I'll come up and up and up. I've got everything looking good so far. Now, we've done nothing much to it here. We've got our structures in place. We've got roughly where these things are going to go. I want to maybe move inlet 3 down to be opposite inlet 4 here a little bit. So I'm going to hit my edit button, find my, select that structure, inlet 3. And I'm going to choose its XY, this northing and easting. I'm going to pick a point and I'm going to choose a near snap opposite of inlet 4 there. And there we go. So I'm now also on inlet 3. I'm going to add a pipe. So I'll go to my pipe and I'm going to choose inlet 4 to also be a connector. All right. Now, what else do we see? I'm going to save my network so far, but I haven't really looked at much. But if I want to get a sense of how this is progressing, let's go all the way up. Let's go back down and choose that. We'll come all the way up system. And let's look at our drainage tab at this point. And remember, we could type in these values, these drainage areas, time to inlet, runoff coefficients, et cetera, et cetera. Or you could choose that pick button uh, and choose a contributing drainage area. Or you can choose this calc button. And if you choose the calc button, notice it's reading that surface. Over here on my command line, you see all those different triangles it's reading.
Yeah.
So when you calc, it's going to basically do that sub watershed analysis, and it's going to find where we put that inlet, that's what's going to feed that inlet. Okay, so some over here actually jumps our road curb and comes down here and collects in there. It calculates the time to inlet, calculates their drainage area, composites that runoff coefficient of 0.59, just like we've been doing all those things before. You can also add, by the way, these known flows. So if you've got a pipe that comes in from off system somewhere that you know has a certain amount of flow, you can add that to your inlet. Okay, so there's that one. If we go downstream, do the same thing under our calc. So that's what contributes to that one. Okay, the 3, and then let's go to our pipe, choose that pipe, go up, and let's see what comes into 4. So back to drainage, we calculate that. Now you don't have to do this. It's actually going to do all that. So now you see what feeds inlet 4, because inlet 1 already captured this other stuff. So it's only taking what feeds it down here to inlet 3. and this other stuff inlet 2 is caught, and the drainage on the other side of the center line is going to go to inlet 3. So if I come here and do that calc again, you'll see how that lines up. So it knows how these upstream structures are intercepting flow, and it just calculates those as part of that design. So we come down to that one just to see that. And yeah, see, we get to the outfall, that's our discharge, so we don't have that available to us, okay? If we look at our hydraulic calculations, you can see these, let's put this in as a little less severe. Let's go up. For these particular pipes, and it's as it goes along, it's going to show you those individual contributing areas. So it's calculating our hydraulic, it's the ground elevation, the HGL and the EGL. Now notice there's nothing in it yet, right? Because there's no flow. Nothing's been calculated yet. Okay. So we have our system, we've saved it. Now we've got two buttons up here. We've got an analyze button and a design button. And the analyze button is going to go through and look at things and give us a look at it. So it says, all right, I'm going to analyze it, and here's what I found. I got a data problem log. I've got my pipe slope. I've got one pipe at this pipe right here is 5.3% when it's a negative pipe slope. So it's actually trying to flow the opposite direction. So I need to adjust and invert. Another one here, same thing, because my outfall is really too high to come out from wherever that's supposed to be, but we'll check that in a minute. Got some pipe velocity issues, pipe cover issues, a gutter spread problem. I can zoom to that. So I've got too much gutter spread right in here, which you can see we wouldn't, we wouldn't normally have that. We would have enough other things intercepting this before we get there. So we're going to have that one. And some flow depth issues that we've got a problem with. Well, okay, so let's say okay to that. And I'll go ahead and just going to erase that last line a bit. So if I choose the design button instead, so it says you've chosen to design this and overwrite the current design. Remember, the current design is what I've just set in here so far. And I haven't really looked at anything. I haven't set. So it's going to analyze that and start to use those things that we checked on the automatic, like the depths and the pipe sizes and that sort of thing. And I'll say, yep, go ahead. We'll let it do it. It says it's done. And now the only problem we have left is this gutter spread at that.
I had like a max pipe length is 30 feet.
Was 30.
Maybe I missed a setting on that first thing.
Yeah, it should have been 300. Go up to your settings button.
Yep.
And under design, right, not design, but drain, well, no, pipe manhole, sorry, right there. Okay. So you see what it did was it cleaned out those problems, although it still didn't fix this, did it? My pipe is still flowing that direction.
Mine isn't.
Well, yeah, excuse me, gosh. And I still see that this is actually flowing in the wrong direction for me as well. So I've still got some problems, even though I said my design was, I hit the design button and said, go with it. So if I analyze it again, it's only going to give me that. But I want to look at this as we go along. So I'm going to save this and exit, and let's label this so I can get some information without having to keep IDing those structures. So I'm going to come down to my network menu. I'm going to draw sewer network plan view. It says it's done. Okay, so these are drawn. It shows me my pipe flows and all of that, but I want some more information than just what I'm looking at there. I want to be able to see it. So I'm going to go up here to my network settings, and this is in my sewer network setup, my plan view label settings. And when I look at those right now, the only thing it shows me is the structure name. Well, I want to see rim elevation, um, depth, and let's do invert in, invert out, and let's see. That's all I really need for now. If I double click my invert in, I can tell where it's going to go, add the quadrant, the pipe size. On a new row, invert out. The quadrant and the pipe size. And then I've got pipe labels. You can label the pipe length and slope. Pipe size, let's do that for now. And pipe direction marker, either an arrow on the pipe or let's do a parallel leader. Draw the pipe from upstream to downstream, and let's draw them as dash width. See what that looks like. Stack labels. We'll go ahead and use mtext, and that should be okay for now. So now it's going to draw it a little bit more realistically, and there you can see where you see how that, where you want to adjust those, where in the inlet library where it hits correctly. So now I've got a rim depth in, out, and now here's something that is helpful. When you go to, once you've labeled those, you see how they're sort of on top of each other. If you go to the sewer or the network menu, go to sewer labels, pull right after you've drawn that, go to sewer labels and choose move plan view label. And if you move this label, notice it consolidates that whole thing and, positions it so you're not, on top of everything else in your system. So I'm going to take this guy and bring him down here. So that should work. Now, I'm going to go, I see I've got, this is a 15 and a slash. I see I've got something in my plan view label settings. I've got that structure labels, structure name, depth, invert in and out. Pipe right here. My size should be inches. I don't need a slash. And I don't need the areas. I'll take them out.
We removed both label name and acres.
Yeah, for here under, yeah, because right now I'm getting the contributing area and I don't really want to see that part.
Okay.
So I'm going to take those out and now I'm going to double check a couple things here. Drawing. Under hide the drawing under in-text labels. And I also want, instead of individual labels, let's make a data table. And let's try that. So now we're going to get these little tables. It should be a little easier. And if I go back, if I want to fix, position to move that around, it keeps drawing those back and forth. So now I see my flow goes a 15-inch from here to here, a 15-inch down in this direction, a 12-inch down across here, and an 18-inch, so it gets bigger and goes 18 inches down. And right in here, it's only taking a 3-inch pipe to connect over to this 18-inch, which is coming across this way. Now, I might want to say, well, a 3-inch is too small. And so I'm going to double click right in, right on my structure or on my table name, either one. So inlet 5. And I'm going to go to that drainage tab and I'm going to calculate that drainage area and see how much it actually brings in, gathers in. Now, who believes a 3-inch pipe will carry that contributing drainage area?
What storm?
Yeah, let's see here. We've got, it's half an acre.
Why? Mine set it right to 18,
Okay.
which probably is a little, maybe a 12 or 15 would have been fine, like the upper ones, but
So if I analyze, yeah, see now my analysis has gotten all out of whack again because of what reason? I'm not sure. Let's see. So that should actually be pretty large. Why is it not? Actually, I think let's go downstream and let's change that structure from that box 2 to a box 3, I think. I want the bigger one. There's 6x4. So that'll be bigger. Go back upstream. That structure was the box 1. Okay. Now let's go down to the outfall tailwater at 30, 60. That should give us some back pressure up the pipe. And okay, let's save that. I'm going to analyze that, see what it told me. I've got some pipe is too fast right in there because you see I'm sitting there at a 3-inch pipe. Yeah, I've got these negative HGLs. I've got all kinds of issues. Flow depth, 64 feet of flow depth. Well, I think I need to redesign. So I'm going to hit the design button and let it redesign. So now we still get some of those issues.
Hmm.
We'll take a look and see what's going on with this. So one of the things that we can do in our settings, in our design, I have my settings button. I look at my design tab and I've got these auto set, the pipe sizes, inverts. So you can, turn some of these on and off that you may or may not want to have it look for. But here's how you can control this. Remember, we're also telling it to pick the pipes out of the pipe library. And so if we look at our library, go back to our network and our sewer network library, and this is our pipe size library, notice that we have several different columns here where we've got these various pipes, but you see these, sorry, I have to stretch these out individually. I've had switched different monitor sizes. But see, this library is, we can set these minimax covers, but it's these pipe sizes. And if I don't want to have them available in my design, I'm going to uncheck them. So I don't want a 3-inch pipe. I know they're not going to work. In fact, I'm going to set 15 inches my minimum drainage pipe. So even my cross street uh, pipes are going to be 15 inches. In city of Pittsburgh, that's mandated by city ordinance.
Yeah.
At 15s and 18s, I don't really need 21s. I'm going to use 24s, uh, 30, 36, 42, 48. Yeah, so those should be okay. And I'll now hit OK so that they're no longer going to be available. And I'm going to hit my design tab again and see if that's going to update that for me. And why is it not? Come save, exit. Oh, it had to exit. See, it puts a 96-inch pipe there. There we go.
Oh,
It's a lot more sense for the slopes that we've got. Now, it's supposed to update while it's in that network, but apparently it doesn't on mine here with the AutoCAD side. So if we look at this information, we can see that we need, a lot more infrastructure. This pipe is okay, but then it needs to jump to a 66-inch pipe at 7% slope. Now, before we get too far afield, I'm going to exit this for a minute. Remember our 3D viewer?
yeah.
View our 3D view drawing viewer. And now this is just the drawing itself, but because I'm not even looking at the surfaces or anything like that at this stage. And I see when I look at this, it actually recognizes that those are parts of a pipe network, and it actually creates these as 3D structures, see, and puts those in there. Now I've got,
Oh, that's cool.
now again, this is just for the drawing viewer, but you can actually have it generate those. And there now I've matched, I matched my inverts and not the crowns, you see. I've got a 15, it goes across, picks up a 66, and it's got these other huge monstrous pipes that I really do not need to have quite so large. But what do I got? Let's look at some depths up here. I've got a 10-foot depth there. I've got a 9-foot depth here. Well, why am I starting so deep in the ground? So if I go to, to that particular structure, I double clicked it. I'm back on inlet one. Let's change my depth from 9 feet, which gives it an invert out of 366. Let's only make that a 4 foot, which now pulls that up. Okay. And if I look at my pipe, that pipe's going to be a 26% slope. Now, I wish these labels would update, and it's not. Are yours updating?
I think so. I'm not sure.
Mine are not updating
Yeah,
until I exit this, and that's when it re-updates. But these are supposed to update as I make these changes, and it's not working in the AutoCAD version, or at least in this version, 2024. 2025 may be what's doing that. So anyway, if I go from there, a 15-inch pipe, and instead of going down at those
yeah,
crazy,
mine's updating.
okay, yeah, see, mine's not, and I don't know if it's a Zoom thing or what, but let's fix these slopes. So I'm going to start down at my outfall. I tell you what, instead of so what's forcing these huge pipes is because I'm picking up all these drainage areas up here. And I haven't really got enough system interception going on up here to take care of this ahead of time. So let me
Mine are, I got 15, 15, 12, 18, 18, 18. Mine are all sitting around 18 inches max.
and
Oh, wow.
well, if I redesign, yeah, I've still got these.
Probably because there's the pipes are so big, they're not flowing very fast, right?
But see, now that I've designed, these numbers are supposed to change, and I'm not seeing them yet. So what I'm going to need to
Huh.
do is save, exit, and now it's going to redraw and rechange. All right, so there's a 0.5%, a 15-inch pipe. It still keeps it as a 66 because of this incoming flow up to here. It's just too much. So there's a 10%. So if I take this, let me lower that a little bit. Let's go to, well, it lowered itself. See, it put it down at 343, and it really should be up here at 358. Okay, I'm gonna go to my settings, and let's go from design, let's go downstream to upstream this time. And we'll start down there at 358. 0 point, yeah, 358. Save that and design. I can live with some of that. There's a 10-foot cover right there. All right. So if I save, exit, let me look at that in my 3D. Yeah, so there's a 4 foot depth. All right. So I don't know why yours is doing those. See, there's a 6%. One here catches and comes across. If I were to put one, I'm gonna put something over here in this ditch. And I'm gonna basically make this a culvert. I'm not worried about the cosmetics of it right now. And I'm going to do another culvert to culvert over here. So if I add something that is going to pick up there, I add another one. Existing pipe found nearby. So I'm going to, no, let's move that. It was a little too close. Pick and pick a point. Let's just put it out here. Okay, now at my pipes, I've got is that inlet 9? Yep. All right, now I'm going to save and exit. Let's move some labels around. All right, now, while there, I will double click him and give him a good depth. There's 11 feet, that should work. And let's come down here and find this guy. He doesn't need to be so deep. Let's just make him 4 feet. All right, let's see what that does if we analyze some slopes, contrary slopes. All right, so we go downstream. Oops, we go here and set that depth to be 4 feet. '62 to '64 to '58 to analyze again. going on here? So 4 feet there. Inlet 7 is a downstream oh, I'm going downstream again now. So I'm going to remove that and go to this and add 8. Okay, now save, analyze. Resume to here. Now we're this way. And I am need to pull this down. Okay. So now back to the structure upstream, downstream. I want it to be here 11 feet. We'll remove that one. We'll come back to this and add as a downstream connector. And at that structure, instead of 11 feet, let's make that 13 feet. Now it's updating the pipe labels. And if I analyze, now I fixed the slopes. I've got some velocity issues. I got some cover issues here. I've got a pipe out of the ground right there. So I would normally drop that down, or I would hit this redesign and let it come up with all right, so what have I got? 10, just over my max cover of 10 feet. I can live with those. Gutter spread 5 feet. Flow depth 190 inches. Something's wrong with that. And save and exit and view. All right, so there's an obvious problem right there that you can see. Now you can also pick that up by the command here under our check sewer network for clearance at crossings, clearance and collision checks and all of that. So if we just add our file, I think it will find that. Let's see. Yeah, there's our system. We open that. Check for, just draw the symbols. So all of these different things you can check, you look for, you can draw the distance between them. So if you're checking crossing pipe distances, we say okay. And it has, see, it's drawn. And let's see, go back to top view. All right, so it certainly dropped the pipe size down. It didn't any better than that. So, but I want to make that depth big, deeper than that. And this is what the design said it could get away with. Um, so if that is, say, a 428 and a 425, see how this doesn't make sense. This shows an invert out, and this does not have an invert in or an invert out. Inlet thing as a downstream pipe. Yeah, let's see. It's not finding the pipes. Tell you one thing I want to do too, though, is to put a structure right there. No. And I'm just gonna get rid of some of that over there. No. And I'm going to connect downstream to 12. And at 12, we'll make that another outfall. And let's have this now design. So it's going to intercept some of this upstream flow. Let's save and exit. Why did it not? See, that shouldn't be that big. Okay, there we go. So it's only taken that much. That's correct now. Um, so what comes into this should be all this other stuff. So that should be okay there. And if we do the same thing down here, sitting on that structure, come on, edit, inlet 7. Choose the drainage, calculate that. Oh boy, that was a wasted pipe. Let's try 9. There we go. So that's what I was trying to do, is to peel some of that off of there. So
Yeah.
put that down, and let's make that 11 feet deep, and inlet 10 will change to another outfall, and it's going to be 13 feet deep. And yes, I know that's not the way that stuff should be going. But let's save that. We'll analyze. Well, still, what's going, where am I? Let me design it. You know, I quite often, Fred, when I'm doing these designs for real, I find this automated design part is not necessarily all that helpful because I may have way too many other constraints in the system. Um, like right now, oh, let's see, let me make that a, well, there was not much inflow there, but if that should be an out, another outfall, no inlet, it's an outfall. Just does not cooperate. Let's see, no inlet, good. All right, so save, exit. So I would normally, make these revisions, have these structures in place, and I would have other constraining issues that I could perhaps, that govern me. Maybe I put, I know ahead of time I've got more need to capture more flow up here and get it somewhere else. I certainly don't need 96-inch pipes for that little bitty amount of flow. I don't, I've only ever on two projects used a 96-inch pipe, and one of them was in a tidal estuary on the west coast of Africa. So it was
Whoa.
very, some really big, huge areas and going out through these burp valves. But in any case, you can see how that is, it's going to iterate through that process. Now, right there, you see I've got a pretty major conflict with that pipe. So I would resolve, that kind of thing.
Yeah.
Now, uh, so we're like way over your time here, but the good thing is you're going to get extra PDHs out of the deal.
Oh,
So,
that okay.
um,
I didn't want to, I paying attention, trying to, you know,
yeah, I'm sorry we wound up into so many little gotchas here, but,
no, that's
uh,
okay. Hey,
I hope
if we were doing, I hate like doing classes and everything goes perfect. You don't learn anything
I
because,
know how to go about fixing something. So,
yeah.
so I would, uh, let's see, what might we consider? Let me see, if I, let me come back out of that. If I go to our library again, our pipe library, let's, see, we didn't even put any pipe thicknesses. This library is all messed up.
Yeah, mine was just zeros for everything.
Okay.
Didn't even have for thicknesses. Just
Yeah, I'm going to actually, let's do this. I'm going to say stop after that. That size now. Let's go back. So what I would normally do is once I get my system started, I wouldn't necessarily keep going back to have it automatically designed because that's where it's resetting some of this stuff and it's just,
But
it's,
like, you may get worse at this point.
yeah, see, that's making 14% slow. That's not too bad. There's a pipe cover issue, maybe too deep. Better spread flow depths. See, these flow depths are wrong. There's something goofy going on with that. And I don't know what that is. It's, well, I do know what it is. It's what it is. I've now, if I save and exit, why is it still 96?
The target flow depth is 0.8, right?
Well, that, let's see, if I go to my pipes, see these, there's a 96 inch. See, that's supposed to be limited to what's available in that library. When I say design up here, see my settings, auto set all sewer pipe sizes. Let's not. Minimize. There's my target flow depth factor, the 80% full. All right, so I'm gonna give this a 15-foot cover. I really want 2 feet per second to get enough scour. 0.5% to 10%, I can live with that. Say okay. Let's save, let's analyze and see where it found some issues. I've got a 14% slope on that cross pipe. So 4.25 to 13. So there we go. I can fix that one by changing that depth. Pipe velocities, way too small here because those pipe sizes are just too big. So to go back to settings, design, let's set our pipe sizes again. I'll add a step up. Let's not do that. Let's minimize. Yes. Rational discharge. Oh, my drainage, let's unadjust. Okay. Save. Let's design. Oops. Design. So if I just drop that depth back down to 11 feet, all right, so now they're going to start changing for me. Okay, lovely. So let's go back to here. Go upstream and look at the pipes. That pipe. See, that should actually maybe be a 24-inch. Let's make it a 36. And let's go upstream. We go up to 5. It's going to be a 15-inch. Go down, go up 2, and the 3. And that will say is an 18-inch. Go up to side 1 as a 15-inch. And you go back down, go back up to 2, and that's going to be an 18-inch. All right, save, exit. And now there's 36, 15, 15, 18. Let's maybe make that a 24. So that pipe is all right, so 36, 15, 15, 24, 18, 15. That should be really sufficient. And I would look at it in my little 3D world, make sure that it makes sense. Boy, I'm really, see, it's pushing this pipe down pretty deep. Uh, Probably because of that right there. When I pushed that down, it tried to push this down at the crossing. So let me fix that. I'm actually going to um, edit that structure. And now let's add the pipe down here to 7. And let's change its depth now. Instead of being so deep here, we'll just be 3 feet. So now it comes down and crosses. Save. And let's analyze. That should be a lot nicer now. We got a couple of pipe velocities, so we need to probably drop that down a little bit. Got some pipe cover issues. See, it's really deep right in there. So we got that 5 foot. Those flow depths really bother me there. Let's see, flow depth is 12. Target flow is 12 inches, 14.4. So that's the size in the pipe. There's something wrong with the water that it thinks it's carrying. That's why we kept getting those big pipes. So if let me switch this to the hydrograph method just for yucks and see what happens. No, that didn't. And it shouldn't have. Anyway. Let me do the watershed analysis. Have it recompute. And Fred, I'm gonna let you go in a little bit. I was hoping to get a little further on this thing, but I don't want to take up
That's okay.
into your weekend here, but um, all right, so velocities. Uh, see, how can it only be going 0.03 feet per second and a 30-inch pipe at a 10% slope? See, there's something goofy going on. These are what's causing it. Well, let's see. What do we got here again? Yeah, and see that's I would bring this up. So if I bring the outfall up, right now it's at a 20-foot depth. Let's give it a 0-foot depth. And hit design, so it should flip that pipe back. Which it did that time. And the depths, I think, I would imagine, are more reasonable now. Yeah, see?
That looks more correct.
Yeah, I wonder what is that slope? It looks a little, uh, is that, say, slope 9.2 and 0.57 at a 48-inch pipes over here. Well, I mean, I could believe it. See this? It shouldn't be a 48-inch pipe right there. These side laterals should still only be 15 inches. I don't know what the heck is it thinking. Well, not enough time to try to analyze this. Start with bad data, we wind up with a bad model. If I, yeah. But anyway, let me point you to a couple of other resources here for you to look at when you get a chance. First of all, on this network menu, if you draw the sewer network, I'm going to draw this in profile. Now, there's all kinds of settings and stuff that are going to come into play here with labeling and such. We don't have enough time in the week to do all that necessarily because it's a trial and error thing. But I'm going to pick my downstream outfall and I'm going to go up to my inlet one. And I'm going to do my profile direction upstream and these might be these HGLs and AGLs. Let's see, critical and normal flow depth. I don't normally draw. See, there's something going on with that. Let's do 2 and 25. Draw existing surface. And we wait for it to ask me for a file. There's something that Zoom does to this file pick dialogues that I don't know what's going on. Just wait for it. There we go. And we'll call it out 2 and 1. And we'll do say 20 scale horizontal. We'll make it 4 feet vertical. I'll say okay. Say okay. And there it is. And you can see the 48-inch, and there's a 48-inch pipe there as well. Existing ground, there's our pipe, there's our structures. And I didn't mean to overwrite this part down here, but there's something else. Let's see, that's we've got going in here. There's 1 to 2, and then 2 to 3. But what is this?
Was the flow, I think, like the flow lines in the pipe?
Yeah, the HDLs and EGLs that I turned on, but what is it telling me is what I'm getting. See how high it gets right here? So it
Yeah.
supercharged that system here, but it should have pushed it up into that one as well. Well, yeah, I don't know. I'll I'll dig into it a little more and see what's going wrong with this thing because I've used this data set for 10 years. And this
Yeah.
this is the first time it's blown up on me. I don't know what's causing it. Um,
You can blame me, it's fine.
nah, 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 nah. Now you've got some tools here, but anyway, you've got, once you draw these in the profile view, for instance, and get things set the way you like those, all kinds of controls there. But you can also go into that and you can edit the structure in the profile view, for instance. So you can say if you wanted to raise this up, different uh, to a different invert elevation. You see how it's moving the structure up?
Yeah.
You can do something like that, or you can even just, select the,
And that'll update the plan view?
and it ties it all back together. So if I wanted to, let's see, edit the sewer structure in the profile view, it says select the sewer entity to move. So if I choose that, see what it's doing here.
Yeah.
Put a little lower down. See how it does that? And I'm going to have to do this one now and also put it lower. And let's pull this guy up a little bit on this end. Yeah, see, that pulls that up. That's what I was looking to see. All right, so that should be, and that should come down here and fix those. So now I've pulled them up a lot closer to being parallel onto the ground. There we go. So yeah, it's a little too high right in here, but you see what happens. You can make those edits in both places. And then we can even, let's see if it's going to let me choose this. Yep, it did not. And if I go to my give it a little bit of a go back to these layers, which were, there we go. So now, let's see, view control. I don't like those goofy triangles, but you can, you can really see, how that would be, actually constructed. You can sort of turn on, what's going on with this. So there you can see if there were some obvious pop outs coming out of the ground, you'd see that pipe, sticking up in the air, and you'd know where to go and revise the prop.
Yeah,
These little bitty things here are just, the edges of the boxes and stuff. They're you like those to be
yeah.
like they are right there. But anyway, just some of those tools. And again, I don't know what's going on with that, but anyway, so well, you earned an extra hour, so
Oh, thank you for the extra time.
actually an extra hour and a half because we didn't do our afternoon break either. Um, so anyway, so I'll send you all that. I'm going to go ahead and I'll stop our recording. And